Look at that. The audio is working and everything. I'm so happy. Welcome everyone. Welcome everyone to Keshe Plasma Reactor Group for Tuesday. It's always Tuesday here at the Keshe Plasma Reactor Group. It's December 20th this time around, 2016. The next to last Plasma Reactor Group of the year. If that means anything, which doesn't, other than tomorrow is the 21st, the most important day of the year. Why? Because the days start to get longer finally.
Yay!
That is so important to my life in particular, and most people that live in the northern hemisphere, it seems. So, well, there we go. That's the intro. That's all I got. Anybody got anything to show, or shall we call it a night? Oh, there's Lee. Lee Coates always has something, so let's take things over to him. And geez, Vivek almost got in there too. It looked like he might have wanted to actually say something. He brought his video up. That's usually the indicator.
No, I think let's have Lee go first.
Okay, you got something interesting there. It piques my curiosity. Okay, Lee, what do you got going this week? You're up to what? Reactor number 64, 8 last week, so I expect you're up to 80 or something. 64. Yes. Excellent. My memory serves me right. I picked the magic number all right, didn't I?
Anyway, this is I don't know. I think it was on your show with a guy from Australia was on there a month ago showing a car reactor with a big ball in the center. And then on Mike Nassif's channel, they had a video where the one guy was going to make one and they were discussing the plans for one. So I decided to make one with a ball in the middle. So we got one of my big fiberglass balls in the middle. It's got a little fiberglass ball on the inside of it, so it's a double ball. And then we got the standard maggrav coil, doesn't have the Gantz ball in the center, with the magnetical output wire coming off that one. This is a gravitational coil. Just springs on the bottom of the big ball. And then the one on the top, there's a little bit of a coil on the top, and then the center of the coil goes into the big ball and drilled in and glued in the hole there. So I won't take that one apart because it's.
Oh, it's actually it goes right into the ball, the wire.
Yeah, that one goes right into the ball. So that's what I'm testing. So.
Wow. So still no direct connection between the two maggravs other than the fiberglass ball.
That's right.
But you've got one wire on the inside and one wire coiled around the outside. So it's almost like a capacitor in a way, or an inductor at least.
Yeah, well,
in a minor way, they're small wires, but it still could be plasmatically linked.
For the small ball inside the big ball, the idea came from Mike Nash's group. I got some little bit of lead Gantz, maybe 10%, or Gantz water with a bit of Gantz in with it, and then there's caustic soda. There's a little bit of aluminum foil in there, so it's that's breaking down into hydrogen. And then I put just 30% CH3 because my fiberglass ball was CH3 around it, so I figured I'd throw a bit of that in there.
Holy cow! So
outside ball is just plain CH3. So.
Okay, so you've got how big a piece of tinfoil did you put in, and how much caustic? I'm wondering.
Well, it's about.
And is that why you're holding it so far away from you? Well, I mean, we got to be careful.
I put too much tinfoil in it because I couldn't glue the hole up. It kept bubbling out.
Yeah, right. And the thing about
I had two little pea-sized balls of tinfoil in that one.
That's quite a bit, yeah.
And then I did a second little one I was going to spin here, and it's got just one little pea-sized ball, but again, it keeps bubbling out, so I haven't got it sealed properly yet.
Yeah, and the trouble with the tinfoil is if you have a strong caustic, then it'll start like aluminum forms a oxide immediately in air, right? It just you can't see it, but it forms an oxide, and that's what protects it from corroding further. But with the caustic, it has to eat through that oxide first, and it takes some time with tinfoil. Once it eats into it, then it starts the reaction much faster, especially if there's heat involved and so on. And that's how kids on YouTube blow up Coca-Cola or rather soda water bottles with just doing that with some caustic and tinfoil, and the pressure is so great it can actually blow up those bottles, which is quite a bit, probably 150 to 200 psi or something like that. So,
yeah, like it was it's been bubbling. They bubble for about an hour or so. Just that.
yeah,
Have
if it's
a
if
little
it's
bit of
gonna
tinfoil in there.
bubble, if it's gonna
So
bubble, and if you got a hole to allow the gas to escape, then that's a much safer way to go about it for sure.
yeah, well, yeah, and I sort of tip it over on its side a bit, so there's a little dome in there for the hydrogen to collect, and
Yeah.
then so I'm not getting air replacing the hydrogen going in and stuff.
Right, right.
And
That's the other
then I
part.
try and glue it, but then it bubbles through keeps bubbling through the glue.
Yeah, yeah, and like Mr. Keshe
So,
says, we want to build up the pressure in these cores. That's part of the, the teaching basically. And that's definitely would build up pressure with the hydrogen pressure inside there. That's
yeah, like I put a screw in the hole first, but
yeah.
that wasn't hydrogen proof. So
Yeah, hydrogen is pretty tiny. It'll escape out pretty much any hole at any
yeah,
hole
so
available.
anyway,
Cool.
that other little ball is the same composition as this one. I was just going to put it in here and spin it and see what happened. So the
Hmm.
other thing, there's inside these little balls, there's an infinity loop with a 3-wire infinity loop, the kind that Mike Nash always makes, glued right in the middle, so that when the ball spins, you're getting the fields collecting around the infinity loop. Supposedly
Is
that's
the center ball is it loose inside the other ball
on
or?
this one. It's just loose. Okay,
Hmm.
uh, it would have to start spinning on its own to do anything. So I'm doubtful it's going to do that, but who knows?
Yeah, who knows?
But at least I've never had one. I should make put that little ball inside a clear acrylic ball and just see what it does. But
Mm-hmm.
I wasn't. I don't know. The boys at Mike Nash's channel, they kind of thought it was a good idea and they thought it would kind of spin, but I'll see. So far, I don't think it's spinning. But
Hard
who
to
knows?
tell, I guess.
It may take. Maybe it'll build up over a week or something and spin. I don't know.
Maybe you'll have to mold in a micro miniature camera into your outer sphere there to watch the action inside.
Yeah, I might have to make up another one, put it inside a clear acrylic ball just to see if I can see anything. And then the other one, I'm going to spin it and see if I had it spinning earlier, but until it sprung a leak again. And then, but you could, I thought I felt some fields around it, so it might be doing something. So that's all I got this week.
All right. Well, thank you very much, Lee. That's great. 64. That seems like a milestone somehow. It's a good number. It's a lot of reactors, that's for sure.
Yeah,
I'm sure you're.
I've another one I just made this week. It had the coils, but I spaced them out as far as I could get them. And then I also had that nano-coated wire connection inside, and it gave me a 4 foot per day field strength. So that was pretty good. So I'm going to do a couple more. I might use a 4-inch cap instead of a 3-inch and space the coils out a bit better. See if maybe that coil spacing will do something. I don't know.
Mm-hmm. Okay. Alrighty. Thank you very much. Oops. And I'll just pin myself briefly here. And Vivek, do you want to show your device, I guess, is the way to briefly
Yeah.
explain it. I don't even know what to say. Let's have a look,
Okay.
and look will be worth 1,000 words on this one. Holy
Right.
cow, what do we got here?
So what we have is effectively two sets of separated magraves coils. They are not connected to each other. The whole premise of doing what we're doing over here is because I had a defective magraves unit with one of our customers here in Singapore. So what I did was I retrieved that unit, tested the resistance live to live. We were seeing about 1.8 ohms, which means the resistance readings are way off. So the idea is to try to rehabilitate this unit by using a strong plasmatic field as the load on the magraves unit itself. So what you see over here, we have two separated coils, this and this. Now the coil over here that I'm pointing to at the bottom is coated only with CH3, and live connects to the magnetical lead of the coil itself. The gravitational lead is coiled up on top of the central sun, which also has CH3. The other coil up here has neutral coming into the gravitational lead, and the magnetical lead is coiled up on top of the central sun. Central sun and the coils themselves are coated with CO2, zinc oxide, and copper oxide. So the idea is that we have some sort of an interaction going on between the two, but with this entire setup that we have going on over here, the idea that we had is, do you remember Armen's give and take system that he did with John Blevin and two magraves units? So that's kind of what we're
Yes.
going to, what we're trying to achieve over here. So this one is connected live to CH3 coil and neutral to the 3 GaNs coil. Up here, live is connected to the 3 GaNs coil. Neutral is connected to the CH3 coil.
Can I break in here for a sec, Rick? I just got a note on the chat. The live stream is only given a black screen.
Who's the note from? Can they refresh, or is someone else collaborate that?
It's John Kammerer. He just put it in the Zoom group, in the group chat, that the live stream isn't transmitting.
All right, can someone else collaborate that? Let me try to collaborate and see if I get on my end here. I don't have that set up yet.
Okay, I'll just mute myself for now.
You can, as far as I know, you can go ahead. Let me just double check on the live stream here. No, it seems to be working fine. I think that someone has, I think John needs to refresh his live stream. All right, let's carry on, Vivek, as if everything's okay.
So, sure, no problem. So the way that we have this configured, as I mentioned, is the give and take system that Armen came up with the two magraves units, and they are wired opposite of each other, and they connect out to the grid, they connect out to the load, and you essentially have live flowing through the stackers in one magraves, and you have neutral going through the stackers in the other magraves. So that's essentially the give and take system. So that's what we are trying to do over here. I've put in a bottle of the 4 GaNs mix over here, CO2, CH3, copper oxide, and zinc oxide, over here as a so-called central sun for this entire setup that we have got going on. And what we want to do is create a really strong gravitational field, or rather a gravitational bias right here in the center. Now, what's interesting, if I move the camera a little bit closer, let's see if we can get in on this. Yeah, okay. The GANs is stratified. Now, when this bottle sat on my shelf, I did not see a visible stratification. However, as it sits here, I think you can see that the copper oxide seems to be right on top of everything else. I don't know how well that's coming out on the screen, but that's what I'm seeing over here.
Yeah, we can pretty much see that. Yeah.
Yeah, so that was a very interesting observation that, you know, as this bottle sat on the shelf, it didn't stratify, it was uniformly brown, but as it sits in here, it has stratified in this way. So we're gonna see what happens as we go along. The connection.
Hey Vivek, I got a question for you.
Go ahead.
How you see it separated there?
Yep.
Have you cross-referenced it with the atomic weights of the nanos? So it's just like regular separation rather than caused by fields.
Okay, the thing is,
Yeah, we do that with the GANs ring. When we spin it in a ball, it separates according to its atomic weight with the centrifugal force. So you see different rings according to the heaviest in the middle of at the equator of the ball, and then other rings kind of going up in bands from there, up and down actually.
That's right. I did not do a quantitative or qualitative analysis in that way. All I did is a very basic observation that when this bottle sat up on the shelf, there was no stratification that I could see. But as it sits over here, then it started stratifying.
What are the layers again, Vivek? As far as you got the CuO on the top.
It looks like copper oxide on the top, and looks like a darker brown below that. I'm going to say that's CH3, and CO2 and zinc oxide below that. That's what I'm seeing.
Yeah, and all the static systems that I've seen where police have just mixes in jars sitting on a shelf, unless there's some energy input into that system, it just stays mixed. It doesn't stratify. So there's definitely something going on here for sure.
That's right. So that's why, you know, both John and I felt quite optimistic about this setup over here, which we have got connected to the magravs, as you can see. It's connected to the multi-plug, and then the faulty magravs is sitting over here. And I've got a bottle of 3 GANs, copper oxide, zinc oxide, and CO2 sitting on top of that. So, and I have a bottle of CH3 sitting on top of the circuit breaker at the entrance of the house. So I've been monitoring the electrical consumption every day, and so far there has been no reduction. But this unit was only connected a week ago, literally to the day. It was only connected a week ago. A couple of days after that, you know, some of the configuration over here changed. So we're going to monitor this over the next coming weeks. Probably next week, what I'm going to do is disconnect the magravs unit and do a resistance test again. And once I do a resistance test, then we can see where we are with respect to with respect to where we started from. We started at 1.8 ohms live to live, and I'm hoping that when I test it next week, we should see an improvement. We should see higher resistance readings. At least that's our hope. So yeah, that's what I wanted to show. Does anyone have any comments, suggestions based on your own experiences of this sort of a magravs configuration? We'll be very happy to hear them.
Yeah, I got something that might help you out. A little suggestion.
Yeah.
For one thing, you when you do the cylindrical coil wrap, when you make the coils, right? It's
Yeah.
of cylindrical design. But how about you try something like this? Just give me a second to pull it up. There we go. I'll do a screen share here, and there we go. You guys see that?
It's a it's a braided form of wrap.
I'm still talking to the guy about it. It's Stefan Mans from the GANs group there, Golden Age GANs, and yeah, I've been talking to him for a while. But it looks like it's braided, but apparently there's I think an inner core as well.
Okay.
I'm not too sure, but it's more about the geometry of it and the flow, because as you can see, just naturally looking at the thing, you can see how it kind of flows, and you can almost see eminence around it. And that's what you'd want to do for your field too, because that's part of the fractal to get the fractal energy going.
Sure.
Try that and see how your reaction is. Plus, for nano coating, I've been noticing for the results of people using it is the organic hemp cloth for nano coating.
Unfortunately, I don't have any of that over here. So, well, I live. Let's put it this way: I live in Singapore, so anything remotely suspicious as far as drugs are concerned, is punishable by death. Silly, I know, but it is what it is.
Wow. Well, that's all I really.
Yeah, I'll try to. I'll give the other one a bash. The braided configuration. It looks very interesting, but also I have the same question that came up in my mind that when I presented the Flower of Life last year, and I used a braided configuration. I remember Mr. Keshe saying, "Don't braid your wires because it causes nothing but issues with the plasma fields." Maybe in this configuration, it actually enhances the field. I don't know. So I'm willing to give it a go and see what happens. That's a very interesting looking health test.
I got another one for you guys too, so you can see that it's a dual. It's there's an inner core. Just one second here. There you go. If you can see it, you can notice how there's an inner core, right?
Yep.
So, but you can see how it'd be fractal. It'll really be good for fractal because of the geometric pattern of it. It would imply natural resonance. So, especially with inner core braiding, it looks more just like tight twisting to me, kind of thing. But these look like braided in kind of infinity loop fashion.
Right. John, do you have any extra wire over there that you could try this with?
I got some wire. I got to make up another set of maggrav coils because the last nano coating failed miserably, and they just turned into like a dark red, sort of dusty, gross mess, and it didn't coat at all. Mr. Keshe did caution us about using the twisted wires in that fashion, and the basis for it was you're disrupting the congruous magnetic and gravitational fields. When you have a wire twisted like that, you don't have distinct field sources. You've got them all mixed together. So yes, you're going to have a massive amount of interactions within that system, but you're also you're limiting yourself in the what would be the word, the magnitude of the plasma that you can access, because you've got so many little tiny interactions, it never gets a chance to build in any significant fashion.
Yeah, that's basically the way I understand it too. The way I remember Mr. Keshe saying it was pretty much what John said there, that the twisting breaks up the plasma into little individual pieces rather than a continuous flow. So it might be useful in certain instances. Maybe you want to break it up into more usable chunks or something like that. Or maybe there is the idea of putting an array of smaller items together can enhance and make, you know, the sum of the sum of the parts is greater than the whole. No, the whole is greater than the sum of the parts is the way it goes. In any case, you get a bigger effect with a bunch of small parts. There's certain antennas they make that way. You know, you were talking about fractal earlier, and there's a fractal antennas that use many small parts, and they're all pulled together. And when they're all pulled together, that end product is actually greater than just a normal antenna. So
Yeah.
something
Peter,
to
one
be
thing you
said.
can do for us, if you'd like, the longer of those two pens strikes me as it would be a little bit better for this test. Finish the project, finish the process, nano coat it, get it ready to go, and then do the ice test. And see if we can visualize the field coming off of that and see if there's a significant difference between that and a standard straight coil.
Stefan there, he's the one that does it. That coil is already nano coated using the organic hemp, and it does a gold nano coat onto the copper and things.
It shouldn't be gold, it should be black. The whole purpose of the nano coating is to absorb the fields. If you're not absorbing the fields, then you're not getting a black coating. That's why it's black. So I'm questioning your nano coating methods as well. Again, you may be fine. It may work really well. It may be tailored for a very, very, very specific purpose. So it may not necessarily be incorrect, just not for the system that you're working with specifically.
Well, I'm not personally doing that. That's just from someone from the group.
Yeah, there's lots and lots of people out there who have all kinds of ideas, and some of them are really valid. Some of them I have no idea where they came from. A few of them absolutely make no sense whatsoever. And again, we're just starting out on this, so we're all working from our own limited perception of these processes, and we're all learning as we go. But the description I was given, the way I understand nano coating is, if it's done correctly, it absorbs all of the fields. And once, actually, I've got a pair of coils here that are really close to that. The nano coating is so black, it looks like a hole in reality. It's absorbing everything. And that's what we're looking for with the nano coating.
Or there's a possibility that you use different metals too.
Certainly.
To come up with a different color like that.
Yep. But it's from his description, it was copper coils, and he used a different coating method. I don't know what this hemp cloth coating method is. That's the first time I've heard of it.
Yeah. Here we can get some anyway. We're in Canada. It's all right. We don't get chopped and killed for that. But Pete and I, we know each other, and we're gonna check that out. I can do my own little coil design. I never tried braided like that. It's kind of interesting visually.
Well, I find, it doesn't necessarily, the braid is there, it's worth more testing with stuff like that, but, and it also depends on what you use it for. But I'm more into using, more geometric coils and stuff like that. So, instead of just a straight, cylindrical, you can go trapezoid or, kind of like that, chestahedron, triangle. What's the other one there? Hexagonal, nonagonal, things like that.
Yeah, when we start adding these geometries in with the plasma fields, what essentially what we're creating are focal points within the plasma fields themselves. And that's definitely useful. That's something that's going to come in, that's going to be very important when we step into the material creation aspect of this. So, I don't want to discount the geometry. Certainly it does make a difference, and it's a way to focus the fields at a very specific point. Who was the fella in China? What's his name? The musician guy. I can't remember his name. He's going to kill me.
Train.
Mario, that's his name.
Mario Train.
He discovered that with his because he's using some pretty funky geometry on that, and he has seen the focal points in his systems, and so we know it does exist when you're dealing with a spherical, a series of spheres, and they're going to interact at certain places. If you can get several spheres to interact at the same point, you're going to get a very specific condition at that point, and a millimeter to one side, and it's going to be a completely different condition. And again, this ties in with twisting your wires together like that and making the twisted coils and then wrapping that into a coil. Is you're going to have so many of these little focal points all over the place that any interaction, any plasma that's within the system isn't going to get a chance to actually build to any significant amount. So this is what we might see with the ice test, and that's why I'm curious to see if there is an actual disruption in the field, because we've had enough of these ice tests now published that we can see with the basic round coil 2 coil 1 pin health pen, we get a very specific type of field shape. We know from Vivek's experiments with his Qigong guys that the length of the pin matters. If it's too short, all you wind up with is a toroidal field around your coil. It doesn't emit the plasma, because anything that's coming out the end of the pin gets sucked up into that toroid field and turned back on itself.
I'll be quick.
Yep.
I'll ask Stefan there if he has any pictures, because I think he has done that with this type of nano coating method. I do think he has that, so I'll talk to him and see what he has, and if not, I'll tell him to do one of those.
Yeah. The more data we can get, the better. The more various systems we can get. Even a system very similar to that, but with the pin that's say 50% longer than the coils. One that's 20% longer than the coils. We know that makes a difference. We know the longer the pin, the tighter the beam of plasma energy that comes out of the end of this pin. And you can tailor it. You can get it. There was one that was just on the edge, and it was pulsing. The Qigong guys, they could see the power coming off of this, and they're saying this is coming off at a pulse. So, we can tailor the systems in that way as well. Whether the geometry has a beneficial effect or a limiting effect, I don't know. Whether the twisting the wires together like that has a beneficial or limiting effect, we don't know, because we just don't have enough data. But for something where you have a strong field built up so that you can emit it, you don't want a whole bunch of little tiny interactions. You want one big interaction that builds and builds and builds until it just can't handle anymore and it squirts it out.
Just out of curiosity, does the gentleman who does the nano coating with the hemp cloth method, does he have any resistance readings that are on hand that he can share?
I'd have to ask him. I don't know if he's on right now, but I'll need a little bit to talk to him there. But I can definitely ask him and see if he has at least some analysis of it.
Sure. It would be very interesting to see the resistance readings across copper that's been nano-coated in that way.
Yeah, he's the same guy that's been doing the Q devices and things like that. So following Mike Nashif there.
He's been in the group here a couple of times before.
Yeah, and so I'll talk to him and see what he can provide.
Sure, it'd be interesting to know more about that process. Go ahead, Vivek.
Just like to very quickly wrap up my part of the presentation. So just to wrap it up, I have color-coded wires over here on this bottom box. What you see is brown right here that's connected to the bottom coil, that's live, and blue up there connected to the top coil, that's neutral. However, up here, although you see brown connected to the top coil, that is neutral because I've rewired it at the plug. And blue connected to the bottom coil, but that is live. Okay, so that's the way that the give and take system has been configured for this setup. And I'm going to run it, see what happens, and we'll keep you all posted. That's all for me. Thank you so much.
Very good. Thank you, Vivek. Alrighty. Well, let's. Any other questions for Vivek, or shall we move along? I see Salma has his hand up there. Is there? Did you have a question? Hello, Salma. Can you unmute, or maybe you didn't want to have your hand up? I'll lower your hand and you let me know. Just go ahead and talk if you need to there.
Hello, Rick.
Oh, hi.
Hello, everybody. Knowledge seekers. All that I know and all I gonna know later. Rick,
Hello, brother. How are you?
doing well. Thank you.
Oops.
Rick, I,
Sorry.
I think maybe I'm like behind and all that. But what I need to talk about is the superconductor. Has anybody touched on that? Because
Well, not today, but
on
go
the
ahead.
148,
What would you like to talk about, superconductor?
because on the 148, Mr. Keshe says use chemical to melt the copper. You remember 148 near the 113 mark?
To melt the inside of the wire, you mean?
Yes, to melt the copper from the inside.
Right.
Yeah, so I tried nano coating with cold caustic. Okay, so what I
Mm-hmm.
do, the plastic tube, I wrap it with coil, copper rod, and copper tube, and I get traces of nano coating on the outside and the inside where you can slide it out. You know the tube, the copper tube, you put a plastic tube inside.
Mm-hmm.
So when you're ready, you just pull it out without melting the copper. You get that? The tube, the plastic tube is in the copper tube.
Right.
Loosely. So you get traces of nano coating on the tube.
Right.
So you don't have to melt. You can only slide it out.
Why do you put the plastic in at all if you have a tube to start with? Why do you need the plastic in the middle?
Because Mr. Keshe says the plastic need to be nano coated so that you get superconductor, real-time communication, levitation, and positioning.
Inside the tube? You put the plastic tube inside the copper tube?
Copper tube. Yes. So the copper tube is nano coated with traces on the plastic.
Mm-hmm. Okay.
Has somebody done anything like that?
Well, people have put definitely are putting tubes inside of other tubes, and I think there are people that have put plastic tubes inside of copper tubes, perhaps. Yes, I remember one with a fitting that had a hose that went all the way through the tubing, and it had like a fitting in each end, so you could have a separate thing going inside. But that's a little different than the copper wire that I recall Mr. Keshe talking about, where he was saying if you had a copper wire and you nano coat the outside of it, and then you could melt out the inside of the wire to make it into a tube or a cylinder, you might say.
One person I know is what was his name? John Omang of Arizona with the 16 stacker.
John Bliven,
It-
is that what you said?
On the
John?
149 workshop,
Mm-hmm. Yep.
he was using the same thing in for superconductor. He tried it. So anybody else tried it and a successful outcome?
I'm not sure. I don't know of any particular tests done with the tube as such. How were you envisioning it? Had you made one, or just thinking about it? Like,
Yeah, I just put coils. Coils and infinity loop inside and outside the plastic, and it will bring traces of nano coating on the plastic.
right?
What I use is a cold caustic.
Mm-hmm.
Yeah. So
Yeah. Well,
when you
that's
layer it and it become dark, you just take out the copper wire, tube or rod, and you keep layering it more and more. We continue with the traces, and you make it you layer it more.
mm-hmm. Yeah, that makes
But
sense.
this is done with cold caustic, and this you don't have to melt the copper inside the wire, inside the tube, like our normal wire.
Right. I see what you're saying. Well, possibly. Yeah. If you can get the plasma going and keep it going inside there, and it doesn't, dissipate on the walls of the reactor as such. That's the whole idea. That's
Yeah.
the main rule: is don't let the plasma hit the walls of the reactor, or you lose the plasma essentially.
Correct. Instead of using copper, we go to plastic, where you even put plastic and then put another plastic inside the bigger plastic. That's what Mr. Keshe was referring to.
Right? Definitely, that can
Uh,
be
uh,
done.
I'm just putting this in the air because it is possible to do cold caustic.
Definitely, it works very good with copper parts. When you put them in a baggie and spray them with a bit of cold caustic, yeah, I think that's an amazing process. You just zip up the baggie and let it sit in a warm place for a few days, and bingo, you've got your beautiful black nano coating.
Longer the better, no?
Yeah, seems to be.
If we can get superconductor with this process, is wonderful. It's a very big step. Huh?
Yeah, well, this whole thing of superconductor is a little hard to put your finger on, because even the scientists aren't really sure about the superconductor thing, and they say that they don't have any room temperature superconductors yet, but at the same time, they do have this, I think it's called a pseudo superconductor or something like that. It's sort of like superconductor, but it's in the high temperature range, meaning like at room temperature. Most of the experiments with superconducting is done at 1 degree Kelvin, or up to maybe 5 or 10 degrees Kelvin, which is what, minus 270 degrees or something like that. So it's
Correct. So I think is from Arizona, the guy with the 16 stacker on the 150 workshop, he was using a superconductor, but superconductor, I think nobody tried it before. What you do is just like aluminium. When you try it in the beginning, it's very light. It's very light. You remember aluminium when we tried, we couldn't get anything. When Ali said cold caustic, then everybody started with aluminium cold caustic. The effect will be the same. You only have traces in the beginning, but in the end, you will get it solid.
Another thing you need to keep in mind, though, when you're speaking of this, is a superconductor for what? What are you trying to transmit? The copper
Mr. Kes,
the
Mr.
copper
Kes,
nano coating, the copper nano coating is a superconductor for plasma, super insulator for electricity. We're not
yeah,
building superconductors for electricity.
yeah, we're going for superconductor for instant communication, levitation, and positioning, according to Mr. Kes on the 149.
That's right. But what energy are you working with?
Nano coating first.
That's not
Okay.
energy.
Yeah, but the the fast space that it give you everything.
Well, making a superconductor for plasma is ridiculously easy. We're all doing it. We're already doing it. It's not an issue. Nobody is having a problem with it. And
So
as long as
people
we
are
don't
doing it.
try to make that work for the matter state, we're fine.
No, 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 no.
From
Not matter state. Not matter state. This is minus the copper. If anybody do it with the ordinary wire, you need to melt the copper. Can anybody do that? I don't think so.
Well, the biggest issue with that is there's nothing to hold up the nano coating, and it'll just crumble. It'll just turn into dust and fall on the floor.
No, it doesn't.
Copper is a structure. The copper is a structure that holds that coating up.
Yeah, correct. But with traces of it, you can add on layering after you take out the wire. That's what I'm trying to say. Wouldn't it be wonderful if you have nano coating on the plastic, like what Mr. Keshe asked us to do?
Well, then you're simply replacing the copper with plastic. You're still in the matter state.
Correct, but Mr. Keshe says it's a superconductor with the plastic, but not with the copper.
No, that's I don't think that's what he said. What he was talking about is having the nano coating without the matter state present. Okay, no plastic, no copper, just the nano materials, which right now we can't do.
But on the 149, he says nano coat the plastic, okay? Then put another plastic inside the plastic, if you remember. Rick,
Nope.
any idea? Your thoughts?
Well,
I got a few thoughts. Really, if you're looking into superconductors and stuff, even with plasma, and if I know the nano coating is already a superconductor, but one upgrade from even the nano coating of copper is you'd want to use silver, because the conductance value of silver is up at 6.5 million units for conductance, and copper is only at around 1.6 million. So initially, you'd want to use silver to replace the copper. Then,
well, they don't use silver for superconductors, though. They use copper because of its peculiar qualities.
How about gold?
Gold's a supercapacitor.
Mm-hmm. But, well, we're getting a little far astray here because Mr. Keshe has a different definition for it being a superconductor and so on than this normal scientists do. Go ahead, Mario. You have some clarity to give?
Yeah. If you nano coat your copper wire and you put your ohm resistor on there and you have 0 ohms, then you have superconductor. It's a superconductor, isn't it? If there's no resistance.
If you're measuring it with electricity?
No, that means there's ultimate resistance, not no resistance. That means there's infinite resistance, meaning extreme resistance, not no resistance. But that's measured normal to the wire, though. That's like from the middle of the wire where you have one lead connected to the outer skin. So that makes it normal to the wire. If this is the wire and your probe goes into it, you're measuring those layers through the layers, and that's infinite resistance or in the megohms or hundreds of megohms range. But if you're measuring lengthwise along the layers of the nano layers, then you can actually get, you'll have less resistance. You'll have a measurement of voltage along those layers.
So there, in every single
Correct.
layer,
You're
you will
correct.
have superconductivity, no?
Well, you might have superconductivity in the layers. It's possible, or plasma going on. It depends on how the layers were constructed exactly. And as Mr. Keshe says, the gap and the spacing, like the gap between the actual, elements.
Layers.
Well, the gap is between the elements in the layers, and then the spacing is between the layers themselves. So you have gap between the individual atoms, let's say, and then which is already spread apart compared to in the element copper, they're all tight together. And in the next layer, the nano layer, they're more spread apart and loose. But then they're all layered up in layers as well. So they got the gap and then the spacing, which are both important. And
You're correct, Rick. But let me refer you to the 150th, where they try the superconductor. They use plastic, and they managed to nano coat the plastic, and they are still using plastic, I think, rather than metal.
okay, did they get? Who is they? I can't remember who they were. You talk about Renan?
Arizona tried it
Okay.
with the
Right.
16
And what was their
No
success
problem.
with it? What did they get out of it? Out of their superconductor? Did they get
It
lift
wasn't
or?
successful.
Pardon
It
me?
wasn't successful.
They were successful?
Unsuccessful.
Unsuccessful. Okay.
But
So
I don't know how they nano coat. What you do is layering cold caustic, just like what we do with aluminium.
well, why don't you try it and get back to us on how well it works out? There's so
It's
many
just that
different things. I mean, we can't just drop. I can't drop what I'm doing. I've got a coil up there. Hand me that coil up there. That tube. I've got a tube here, similar to what you're talking about. Plastic tube, GANS water in it. It's been up there for probably 2 years now, sitting on my wall. I haven't been
like this,
able to
I
do
will
anything with
advise
it.
you use a copper rod inside and a copper tube outside. Both you can slide in and out, no problem. You don't have to melt them. You get that?
Yeah. It's fairly easy.
Right? Yep.
And you can coil or you can use a copper tube to get the first layer or traces of nano coating. So I don't think I'm far off because Arizona is still using plastic.
Okay, well, we'd have to see a design and actually work with it to get some clarity and get some results on it and so on. So otherwise, it's more theory than anything else until someone actually builds it. It's an interesting idea.
But what I think is the superconductor is the way to go. Instant communication, levitation, positioning. I know I'm not that well off in this technical term, but it's
Well, you're
just
right. Yeah,
whatever we
that's
can
right. We
learn.
have to definitely get into superconductor status. I mean, if we had a toroid ring like that ring I just showed, or any toroid, and if it was a superconductor, you can pour energy into it or can draw energy from the environment, and it just keeps spinning, literally, virtually forever. And you can actually store energy in a toroid. Even electrically, in an electrical, toroid, you can charge it up and then draw energy off of it and so on. It's definitely a
So my
technique.
thinking rate, I'm just putting up my idea. You can prove me wrong. You can give it a try. But the thing is, the the signal is go away from metal.
Right. Yes, that's right. I've been working more with fluids than metals these days. So, but everything has its place, and everybody has different ways of testing and trying things. So, and it's whatever you get results with that gets you to the next spot, the next step in your evolutionary ladder, and whatever works for you to get you to the next spot is valid, basically. And it may not work. Chances are it won't work for somebody else, but it will work for you.
Right.
So
I'm putting my idea and my workout so that anybody can improve, anybody can say I'm wrong and all that. But my intention is to put it in the air so everybody have aim.
well, that's right. It's a good point. Sometimes just airing these ideas, like you say, put it in the air, is enough to actually get it to manifest. So maybe the mentioning of that idea in the ethers here will land on somebody's brain somewhere out in the world or maybe off the world. And all of a sudden they'll go, I think I'll make this tube with this other tube inside of it. And they'll think they had this original idea, but actually the idea had already sprung up before, and probably has sprung up before millions of times before. It's just we haven't paid attention to it. So it's
what
interesting.
I'm doing is try to pick on somebody brain cell, Hopefully one of us will get a breakthrough. Yeah, you understand my intention?
Sure, absolutely. Thank you for that.
Okay, thank you everybody, and a Merry Christmas to all.
Okay, and same to you.
Merry Christmas.
Thank you.
Thank you all. Bye.
Is that Denny I heard say Merry Christmas? By golly, it is Denny.
Yes, I'm here. I was wanting to comment on Solomon's experiment, but I'd have to share screen to do that. Just so that I can see that I'm understanding what he's doing. So he's got a plastic tube, and then he's got a nano-coated. He's nano-coating the wire that goes through the center, and then he can either put a coil around the tube, or he can put an actual copper pipe. And then he starts to nano-coat the copper pipe, and he wants then the nano-coating of the copper to taint the plastic. And by having then the nano-coating of the copper to taint the plastic, he then can take the copper tube off of the plastic and pull the copper wire out of the tube, and he's got collected on the tube the nano-coated copper. I'll just call them nano-coated copper filings, just for the sake of coming up with a word. And so now he's got this plastic tube nano-coated with copper filings on the outside of the plastic tube and on the inside of the plastic tube, and he's expecting or wanting that to be a superconductor. Is that what you're saying, Salman?
Yes, correct. I prefer this way rather than melting the copper, or you have to drill the copper out. This is much more simpler.
Okay, so now that I got your understanding, I hope that helped other people understand what you were saying. Thank you.
All the tube and all the rod and all that must be loose fitting so that you can slide it out.
Yes, and so that your nano-coating of the copper has tainted the plastic.
Correct. Traces of it. Then after that, then you do, after removing, then you do all the coating itself, layering.
All righty. Okay, thanks.
Thank you, Danny.
Thank you, Denny, for that explanation there. Alrighty, shall we move along to whatever else is going to be presented, if anything? What do we have here? Anybody else have something they'd like to present at this point in time? How about you, Sandor? You want to show your...
Hi, good evening and good morning for those of Europe. Sorry, I came a bit late. I needed to sleep a couple of hours. Others are making now probably Christmas tree decorations. Now I started to make coils for health spells. And I had a thought that the material cost for a health spell it's less than $1, but or 50 cents or something like that. But there is a lot of work with it. So the nano-coating process takes minimum 2 weeks to have a good nano-coating. So it's worth to make with those effort and time, not one, but more coils to have to give out to friends, family members, and so on. So I had a small box and I saw how many can fit, and I made about 100 coils. And I had an interesting observation when I started the nano-coating with caustic. So I proceeded in the usual way. Just let me open my... I hope YouTube doesn't claim copyrights on my works, so I may share that. Is it okay to share YouTube? Not YouTube, my Facebook page. Okay. Just let me open. We go to share. So share screens.
the best way to do it usually is to share the original videos rather than that, but I think it's okay.
Yeah, I wanted to show I made an album with tutorial to making coils for pens. So you can visit that. I don't want to go through that because there are so many. I mean, when I added also such a easy blueprint for how to make it with interesting parts, and somewhere here it should be the video. Just my browser is freezing. Takes some time to load. So here it is. You see how I poured the water into the hot water over the coils, which had at the bottom chicken mesh, and below it was the caustic layer. Probably I have to stop this and to share the original video itself, because
Yeah, that would be best.
Facebook takes so much time.
Yeah.
Just a second. Let me find again the Zoom window. Large screen. And here it is. Tell me if the image appears.
Yep, we can see that now.
Okay. So This is a 1 foot by about 10 inches or less size box. Maybe it fits about 6-7 liters of water inside. So at the bottom it was a layer of caustic about 1 finger thick. The chicken mesh, 2 layers of chicken mesh, then the coils. I put such a raster to separate the coils to stay all aligned vertically, and then I poured carefully the hot water to fill it. And look, I never seen something like this before. Watch the turbulences, you can see that at the bottom of the box. Like a storm inside, which is normal because there are some. Oh, sorry. Thank you.
So that's what it sounded like when you poured the water in there too. You had the boiling sound and you had the turbulence in the bottom of the.
Yes, but not the turbulence is interesting. Just wait. Have you seen that?
Yes, I have. Thanks. But I haven't. I may have not.
It's repeating periodically.
When you said the caustic was one, when you said the caustic was 1 finger thick, was the finger laying down or is it sticking?
No. Not like we're measuring in the brandy into the cup of coffee. So not, it's just about 1.5 centimeters thick. Look.
Gotcha. Thanks.
I didn't weight it, so maybe it was about maximum 200 grams.
Put any potassium in your caustic?
Yes. I always add a little potassium caustic as well.
Put it
for these waves, shocks.
And you said you used half used caustic in this batch as well, I think.
That's
so it's a little extra back.
That's the special thing here, that I had not enough. I had about. I didn't have enough distilled water to fill the box, so that's why I took some caustic which I used before, and I heated it up in my teapot, and I poured that too. So I mixed 50-50%. The previously used caustic and the hot water. So I see probably there is a strong chemical reaction there also with the zinc of the chicken mesh, which probably produces a lot of hydrogen, but there is something more to it. Because these shock waves which are coming, it's hard to explain just by turbulences. I think eventually the effect of the coils, which are about 100 sets of coils. You know, the health span, it has a central pin and an inner coil and an outer coil. And all these over 100 coils are aligned parallelly and vertically. So maybe that adds something to it.
I'm going to ask you a question that doesn't really pertain to this, but have you used different salts yet in your nano coating and in your water that you even boil? Have you put different salts like your potassium sulfate, magnesium?
Yes, I didn't edit any chloride, bromide, sulfates, or other salts. You know, when we dissolve a salt to the water, or we dissolve caustic into the water, basically it said that it's split into ions. So you have positive ions and negative ions, anions and cations.
That's true.
And I had the sodium, I had some little potassium, and I had the hydroxy negative ions. I didn't add any chloride or something. I don't think that.
Well, if you like magnesium, the Epsom salts would be a magnesium.
Yes. So once upon a time, I used Epsom salt for making gas, but not for making the coating.
Okay, so we see these pulses here, Sandor. Now, does that happen over the entire bottom of the container, only on this corner?
Yes.
It happens all simultaneously, like all at once over the whole bottom. Is that the way it goes?
Yes.
Okay.
That's pretty cool, actually.
And is it regular enough that you could time it down to a few seconds for each pulse?
We can count almost. It's not maybe like a clockwork. So let's count the seconds.
Okay.
So how long did this last?
There's 1,
3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's not regular. So sometimes it happens at 15 seconds, sometimes at 4 seconds, sometimes at 10 seconds. It seems that something reaches such a critical mass, and then it happens at first.
Mm-hmm.
Did you notice if your chicken wire lifted up and dropped?
There is a weight of 2 kilograms of copper over it, besides of the water and the caustic. So it's heavily loaded. The one set of coils, it's about 20 grams, and I had 116 of them. So a little less than 2 kilograms.
So how long did this event take? How long did it last?
So what you see here, this was taken. This video was taken about half an hour after I started the process, and it was going on for about 1 more hour, and then it started to slow down. So it made no more burst after about 1 hour, but it only was it was showing these turbulences only. And it took about almost 2.5, 3 hours to settle down to such a degree that I dared to go to bed. I did this after midnight.
That's quite a long process. Did you by any chance have any aluminum wire in there?
No. None at all, but I had the zinc coated chicken mesh. And I observed here that the chicken mesh became black instantly. What you see, black spots on the coils, it appeared just after I poured the first portion of hot water. I needed 5 minutes to heat up the next one. And in the meanwhile, what was above the level of the water started to nanocoat.
So the noise in the background, that's not coming from the container.
It seems it's coming from.
Do you have
My
a
computer
fan
is
running?
not so noisy. And this was in the night.
Turn the volume right down on the video, see if we hear any. No, it's from the video.
Okay.
Yeah, it sounds like a roaring fire, kind of.
I could see that the nano coating appearing right away would be like kind of like a flash coating process, I guess.
So I have my experience. So if I have some copper right above the hot caustic, just a few millimeters above, that becomes black instantly.
Yeah,
what's in the liquid, it takes time for it.
Yeah, we've known that for a while, Sandor, that the copper that's submerged in the fluids they tend not to nano coat. You don't see any real change until you take them out and they're
Yes.
in a vapor environment.
Yes. Yes. Okay, so I stopped the sharing. So, has anybody any thoughts on that?
I just, hey, Sandor, it's Guy there in the background. Nice to see you. Long time no see, my friend.
Repeat that, please.
It's Guy in the background here. Just want to say hi to my friend, Sandor.
Salut, Guy.
Yes, but I just want to ask you, why do you dip them like that in the liquid? Is it a special type of ending you want to provoke, or because it's like the way we see them right now, like the top portion is, you see all these different coating on it. When you sit them in a liquid like that, they don't nano coat very well, no?
Yes, yes. So I later I removed the liquid by siphoning it with a pipe. I didn't want to pour because you see the coils are organized in some separators.
Yeah.
By the way, I found this kind of separators in a furniture shop, which I don't want to say the brand, but it's known for selling furniture in bits. So this is like a separator for the drawers. And because this was too high, I just cut it into half. So I use these bits to create such a separator here. It's a cheap and rapid way.
Yeah, it works good.
And now this is about how much less than 24 hours. It's maybe 20 hours after I removed the liquid and I started to polarize them with the millivolt meter. Some are getting darker, some less darker. Usually it takes a couple of days until everything is black. So if it's not black, it doesn't mean it's not nano-coated, just there are not so many layers. So when it starts to be black, it's a lot of layers. It's tens of thousands of layers.
Are you moving them around as you check them? Like I see how they're leaning and stuff like that, and you keep moving them.
No. That's why I put them into such holders to have access to one end to be connected to the chicken mesh, the bottom, and the other three ends to be accessible by the voltmeter. I have somewhere a small video of that. Don't want to disturb it now. Let me find the video. Let's see, which folder of the thousands?
Well, all I got to say is, Sandor, see if you can duplicate your experiment.
Probably when I make the next batch, I will be able to see that.
Yeah, I was saying that just so because I'd make you work harder to make all those more coils.
Oh, it was 2 days work. 2 days work to make the coils.
Oh, that's not too bad.
And but it's about 2 kilos of copper. And you don't use it up every day.
Yeah. So there's the rub.
I have no factory, sorry. My workshop is a 1 square meter here. Just let me find my camera folder. I can see now. And on the folder, just let me find the video. It's here. If it's not here, in that case, it will be. Sometimes I use the proprietary software for the camera to make videos, and more often I'm using the Zoom, because that immediately converts it right away in the format which we need in MP4, which is good for sharing. So I have to find the date and time. I think this is
I do most of
Yes,
my.
I found it.
Good.
I found it. It's ready to share. Just a second. Settings, share screen. Let's go without sound. Sorry. And here it is. So this is after I removed the liquid. I had no free hands for a camera when I did that. It's quite an operation which needs some attention. So in order to siphon it out, I fill a flexible tube with water in the U shape. I stop the water running out by my fingers, of course, with protective gloves. And then I put one end into the caustic, down to the bottom, and the other end into a bucket or into another container, which is at lower level than the caustic, so I can siphon it down without pumping. And so here I have the voltmeter on the 2000 millivolts scale, on 2 volt scale practically. So what you read there, it's millivolts. So here I started from the first, going to the second, just touching the ends of each coil for 5 to 10 seconds. On some you find such a couple of millivolts, such a 2-3 millivolts, in some typically some tens of millivolts, and sometimes it jumps over 200 millivolts, so that's why I'm using the 2000 millivolt scale and not the lower one.
So these coils are intended to be pain pens? What are they intended
yes, for? Yes, it's intended for health pens. So anyway, now whenever I do something, I always document it with a little video, so to provide a tutorial for others. So if I see me doing something wrong, to not repeat it, and if I'm doing something good, to have a model which works, which they can understand and expand in their ways. So anyway, this is a long time-taking process. I didn't thought to show you all the almost 1 hour of touching every coil. But you see, touching the middle pin, then the inner coil, just gently to not scratch it, and then the external coil. On some it appears a positive voltage, on some a negative voltage, and so on. It's totally at random. But you see, immediately after I emptied the water, it started to change its color. So the coils started to make a heavy nano coating. And this is amplifying now. So that was it. So the basic idea was to show this to you, to ask you, what do you think about what thing happens there that suddenly makes that burst, which is repeating later when it reaches some conditions. I'm thinking that there may be a chemical reaction directly with the zinc, which is on the mesh, which frees up a lot of hydrogen in atomic state. So is it that reaching a critical level so it makes suddenly that shock? Or it was always in an nano-coated environment?
It could be because you use so much caustic in there that some of the gases are getting trapped down in the structure of the caustic itself, sticking to the caustic, and when it reaches a certain level, it lets go.
Yeah. So anyway, maybe it has no importance at all, but if we observe some of the things while we are doing, we can start thinking about what happens then. By the way, for the coil, that's very simple. I found such a centrifuge vial. It's a Falcon type. It's a laboratory tool. It costs a few cents if you get it, not to the 2 pieces at once, but if you buy them in bulk. So it's just a polypropylene, not breakable. So if you buy a small quantity, it's about $1 per piece. If you buy more, maybe it becomes 50 cents a piece or something like that, or even less. And this is what's inside, center pin, an external coil, an inner coil. Of course, this will be nano-coated. This is just a model to show it to you, so this will not be nano-coated. And a spacer, this is from a plastic tube, a PVC tube, a flexible tube, cut in the size to fit exactly here in between the bottom and the top to not let shaking these parts in. And I chosen that size, which the inner coil fits in, and the outer coil stops on its shoulders. So it holds both of them. And this other part is springy. Care shall be when you when you size the inner pin to stay inside firmly without bending and without shaking. And it's really easy. And I think somebody asked in the comments on the Facebook, so he tries to convince his friends about this technology, but he doesn't go through. So you don't have to try to convince anybody. But you can make a health pen, and if your friend has a pain somewhere, you just give it, so and he convinces himself. He gets his own experience. So this is.
Yeah, that's a nice design, Sandor, and I think you could even put like a piece of paper with a logo inside or something. If not the Keshe Foundation logo, but if you had your own pain pen thing that you were giving out to people.
Anyway, to manufacture new plastic mold, it costs a lot of money. So it's tens of thousands of dollars to make just a mold.
That's right.
But this is already mass-produced in a standard shape, so everybody can replicate it, and it doesn't look bad.
Yep. I've used little plastic test tubes, but the ones that I had are crappy. They break very easily. But those centrifuge tubes, like you say, they're probably
when they are of plastic, there are usually two types of plastic. There is PS and PP. PS polystyrene, it's breakable.
Yeah,
so
that's
this is polystyrene, so
exactly.
You hear by sound, and this can break.
If you step on it, it just shatters.
For flavors, for for spices, for cigars, for tools, for whatever, saw blades. So it's a universal packing, but it's breakable.
Yeah.
And this is unbreakable.
Yeah, exactly.
The sound is different. It's like the food packing.
And did you get them from?
So you can drop it; it happens nothing to it.
You get them from eBay, or where did you end up getting them, or did you get them directly from a manufacturer?
On eBay, transportation costs too much. So I went to one of the distributors of such a
local
laboratory accessories, and I bought a bulk quantity to get it on lower price.
Okay, yeah, but I'm sure they're available quite readily on.
You can find on eBay too. Somebody just wrote he found the 50 pieces for $15 only, which is just the double of price than getting it on bulk quantity. But look, just a second, I have here a box.
Yeah.
So this was the bulk quantity.
Okay.
And this is how they are in. Otherwise, if they come not in bulk, they are packed every bit in a separate envelope and sterile. We don't need sterile, which in operation is cost.
Yeah.
Just have to take it, read the packing for every piece and take it out. From here already, I delivered some bits to a friend, and I still have a lot to give to other friends if I need to.
Yep, and you could probably make some really cool sculptures out of them if you had to too.
Plus, you can use to put in it other things. So
yeah, you can make it into a macro.
Is it nano-coatable, or do you nano-coat?
Yes, it's polypropylene, so you can treat it with caustic.
Very nice. So I bet I guess that you bought probably 100 in there, and you had a pretty good price.
Yeah, actually, this is a box of 500.
Yeah,
100 I given to a friend already. I made.
Okay, I see. Yeah, that's a lot.
100 are now here into the box, and if I will do a couple of tiles more, then it will be. So it will be a good giveaway to friends.
An excellent
lectures.
what do they call it? Stocking stuffer, as they say.
I told you earlier, it was.
Or send some pieces to Italy.
The same idea.
You have heard the call of the Keshe Foundation. There are still earthquakes in Italy, so they need such kind of help as a donation.
Yeah, it's a very nice gift, actually.
Yeah, how to donate if I don't produce?
Yep.
I need maybe one piece or two pieces, but in the family. But
and you never know when a local disaster could strike, and you're the only one in the area that happens to have the paint pens, and that could be
the purpose is I made that blueprint. I made that simple, easy blueprint with not too many words, just the minimum needed. And the purpose is to show to the people how to make it, because I don't want to be the only one who has such a thing. And
I think I got it for you, Sandor. I think you got you posted there. I don't know. I'll screen share and see if this is the one that you were talking about.
Yeah. It doesn't come yet, so. Yes, that's it. Exactly. Thank you very much. That's it. It's easy to understand. It's a 14 gauge thicker wire for the central pin, and a thinner 1 millimeter or 18 gauge American wire gauge 18 for the outer. It's 1 millimeter. Just I didn't specify so exactly the dimensions, because everyone has a kind of rod, which is a thinner, which is a thicker. It's not hard to think about now which rods I have. And I don't want to say you have to use a 4 millimeter rods because somebody may have a 5 millimeter rod. So cannot you do it? Of course you
can. Sandor, what about the coils themselves? Your coils they're like just clipped at each end. The coils are like they're not wrap back on themselves or anything like that?
Yes, that's an important thing. So listen back to what Mr. Keshe told repeatedly about the coils. It was the 107th workshop. I think it was in March, where Guy has shown his creation with 3 coils with extended wires and loops on it, and it has 3 little balls filled with gases in a vial. You remember that?
Of course.
Yeah.
So then Mr. Keshe explained, so if, as he sees, many people are making the wires, the coils with, let me find it, with such an extension. In that case, if you have several like that, so every that extension, it will make its own fields a different strength because the coils are a different diameter. So then, instead of going straight, the flux of the fields, it will go, it will push against each other and it will spread in conical way. So that's why there's no need to use those long ends. And about that thing spinning back, in case if you make something for energy, you make a maglev coil, for instance, you want to keep the fields inside to produce energy and to get the pressure. So that's why in a maglev always you have to twist the ends in this way. But now this is for health, and here the purpose is to have fields to go freely out. So what other way is better than just to have a straight coil? And I don't remember where in private or in public teaching, but Mr. Keshe said, recommended several times that this is the best way how to do it. You put a central pin and a coil, and they have to be not connected each to the other. Don't twist them together. Just this is the basic coil, a pin and this one. And this little loop, I made it only for technical requirement in order to fit here in the center of the cap and to not slip apart. to not slip away. So this is the only reason I made it, because that can be also straight. Of course, when I made it, I took care to make it into the right direction. I don't say the direction that I show it to you because it was so much confusion about which direction is of the. I don't say the word again.
That's why I describe it a standard helix, the same as a wood screw. If your helix is the same as a wood screw, you're fine.
Yes. Yes. So it's simple. It just needs a stopper. You see, if I put no stopper inside, then these things happen. I don't.
But it would sound kind of chintzy to. You wouldn't want to give somebody. It sounds like a Christmas bell.
But there's the rubbing.
Unless if you make it sound like a Christmas bell, now you might have a good product there. You shake it and it sounds like Christmas. You can have Christmas every day. Chinky, chinky, chinky.
And of course, you may extend the coil to the right length as you need. You can extend it or you press it back before nano coating, of course. When you make your model, just find the right length for the coil. What I found for my tube and for my size is that it was something just around the length of such a card. But maybe you can find different dimensions, so that's not a must there. 1, 2, 3 pieces.
Yeah, it's very. It's a nice way to go. I like it. Very simple.
It's easy. Of course, you can put here such a super glue. You know those thread stoppers if you want to make it to be suitable.
Childproof.
Would you put another? Sandor? Would you put another little spacer at the other end so as to immobilize all these? Because I think they avoid rubbing against each other when it's nano coated.
This is the spacer.
Yeah.
And this is the raw material for the spacer.
Yeah, the tubing. Yeah, I did the same experiment where they fit perfectly in my own tube. Yeah.
So what tools I used? This is important to have such clips for the wire, which are not the thick ones. Can you imagine what's the difference? You make a coil on a long rod and you want to split it in small bits to make it faster. You don't want to stop your tool for after every 54 turns and so on.
Yeah, absolutely.
So how you cut it with this thick one compared to this thin one?
Oh yeah. Okay.
So this can fit directly in between, easier.
Mm-hmm.
And for the ends of the for multi-purpose, I use such a twister pliers with conical ones. And what else I'm using? I made my own tool. Look here, a piece of board. I put here some things to stay fixed on the table. In the previous videos, I didn't have that. Now I found where I put this, so it stays more stable. And for instance, this is a gauge for measuring the length of the rod. I put one end there, one end here, and I cut straight near to this one. So I don't have to put a measuring instrument to every piece. So this is for the central pin. So when I make a central pin, first I just twist this one like this. Again, I don't say the direction, better I show it to you. I straighten the wire. It doesn't have to be by hundreds of millimeters. I press this against this end. I hold it here, and then I cut exactly at the sides without measuring. This is a caliper. What I used, a piece of iron plate, some furniture screws, and this is the body of an empty lighter. I have many of them. So it's easy just to drill 2 holes and to fix it anyway. And this other tool, this is a bit different. This is for splitting the long coils into small ones. Look, when I want to make the coils, maybe I have to move the camera in a different angle to let you see that. It has to stay somehow. It doesn't stay. Anyway, I try to do it with one hand. You see, one end I stop there, and the other end it splits exactly where there are 54 turns because I measured it before. This part has to be sharpened, this end. This is not sharp. This is sharpened to fit inside. So don't press too hard your fingers. It's not razor sharp, but it's still sharp. So once I made that, I twist it a little bit and I move to the next. This goes here. So I press it against, and again I press on this one. So I have the next size. I bend it a little bit. So it comes split into portions like this.
Yeah, that's why I don't.
That's like the German sausages.
I was going to say, just like sausages, that's where you got that idea.
Yes. You see? And in seconds, you are able to measure everyone exactly to the size. So it's easy, it's fast. You see, without having it on a table with one hand only, I can do that. And once these are done, now it's very easy. Look, this is the excess. And now here it is. Just cut, just cut, just cut. So this is how to make the work fast. It's not a breakthrough discovery, but maybe it's a useful information. And if you organize your work in such a way to not extend your hand far away to pick up a piece, just to have everything handy in a small area, in that case, when you make hundreds of operations, you save a lot of effort in moving your own, the weight of your own joints. You can work fast if you have everything at small distance. So you can speed up the effectiveness, the efficiency of the work many times just by organizing the tools. So,
excellent, Sandor.
How much it costs? It's made of scrap.
Mm-hmm. No, but it's very well made actually. I do the same, and I know how much, you know, it can take time to take the length and to make sure all your here you got a very easy approach, very nifty. I like it very much actually.
Yeah, purposely I left the rust on them to not look something expensive, to let you see that's easy to make it. It's from scrap metal, from leftovers, from an old lighter. All what costs are the screws only.
Right on. All right, any comments or questions about all that?
And then you turn your little ends just to hold the plasma there. And the sharp end, I don't know if most people know that, but when it's any Sharpies or anything that is sharp, kind of releases the plasma. And that's why we keep a little
The
loop.
purpose is to release it.
Absolutely, yeah. But directed where we want it at the end. So that's why we buckle one end and release it at the other.
Yeah. So this end is only bent with the purpose to stay into this one. So you see, when you're using it, you see Renan's descriptions, you find them on the documents folder of the Keshe.org website. There are about 5 such a PDF files with all health applications. So Renan taught us how to use it, and Mr. Keshe also explained that you are using to send your own energy, and this is just a tool to focus them to a point. It's like when you use some lens to collect the sunshine into a spot. It's the same sunshine, just using a lens, you collect them into a spot to be more effective with the place. So this does exactly the same. So all we have here a spot like a $50 size, here in the middle of the palm, and here too. Usually right hand is giver, left hand is taker, and you just put this here into that middle spot, and then you put your fingers. If you want to help only emotionally, you use only these two fingers. If you want to use also for the physicality, use all the fingers. So these two fingers are connected to the physicality, these two to emotion, and this to the soul. So if you know those, you start learning, of course, experimenting. And then they use this just to focus to the energy which comes out from here. So those who are very advanced, they don't even need this one because they can use their own fingers for the same purpose. But it needs some training. And it needs to get some confidence. Of course, it needs a lot of knowledge to become a therapist or something. You have to study for years to know how the body works. You see, the reflexology points or acupuncture points or acupressure points can be used, and so on. But this is a tool which can demonstrate very well the effectiveness of these technologies. And if somebody has a pain in the shoulder and it passes away in minutes, in that case, he will want to learn more to understand about how and why this works. So that's why I think health pens are very useful.
Thank you for that testimonial, Sandor.
You're welcome. By the way, I sent some webmasters, I hope you'll take care. I sent the blueprint to blueprints at keshefoundation.org website.
Yes, that's my department. I'll take care of that.
I'm also sharing this blueprint everywhere, and I encourage people to share on social media. I just put that copy left, or how to say this, Creative Commons share alike condition for to have it documented. I've seen so many things which became altered, and nobody can track where the altering has been made. So I see people, instead of nano-coating, just putting some ashes and putting some oil, and they say it's the same, which is not the same, of course. Somebody asking, so how about the cold caustic? Isn't it the same, in fact, like the hot? Of course not. Just people have to know to track their sources and to say, so if I trust Mr. Keshe, what he said, then I know he said that. If I want to follow John Smith, what said, in that case, I have to know it's from John Smith and not from somebody anonymous.
Right. So with what you put on the document, does that track it actually, or
it's
reminds
copyright
people?
Protection by Creative Commons. It means you can freely share, distribute, use it for commercial purposes. You can make deviations or alterations of it, derivative works more exactly, but in all cases you have to refer to the source. You have to mention the source where from it came, so people can go back to the original version always.
Right.
That's only the purpose, just to keep a track for which version was done by who and when. So if I made there something wrong, so I stand up for that.
Mm-hmm. Right. Good. Okay. Thank you.
Okay.
Alrighty. So, what else we got? A video on here to fill in while we figure out the next step. The next step in tonight's show. Anybody have something they'd like to bring up, or questions, or their favorite pet project, or their favorite pet?
Maybe I do have a question. Just since you're there, Sandor, you know I got everybody's opinion anywhere all the time, but I'm doing two little health pen. I got the same, basically the same concept that you've been doing, showing to everybody. But
yeah.
You see, you got the 14 gauge copper coils. I use the 14 gauge, and I got my double, even sometimes even triple coils. But and the center pin, I did two things. I did one that was where I attached those little ball with
yes, it's a
GANs
wonderful
in it.
thing.
And I got to mention that inside the ball there was a little coil itself that the whole thing was nano coated, and that was to pick up that basically the energy there.
Wow.
But I had a small gauge wire that was going in through, not exactly a 14 gauge, much smaller actually. I think it was 8 gauge or something like that.
18 usually.
Or 18, sorry, yeah. And I tried another one where actually I made a very big fat pin in this, and that was an 8 gauge or 10 gauge wire that I used, and I kind of put as a central pin, and I kind of split the other end of it, the inside end. Of course, I didn't do all the freezing thing yet, but all this eventually I'm gonna put together and do all some different freezing demonstration with all these health pin that are going to do different designs, slightly different designs. But how about your opinion about that? If I use smaller gauge or a bigger gauge, is it still good, or would it be better?
I think it's not such critical. It's not very critical. It has some practical, technical things about something which is too thin. It's hard to hold its structure. If it's too heavy, it costs too much copper, and actually we use only its surface. Of course, it makes a difference always. But you see, you do this freezing test, maybe you wait for the heavy winter and you don't need a freezer, you just put them out in the yard.
Yeah, we had we had a cold snap here, but just the last almost 2 weeks, Rick? Very cold for the region here, and
it actually froze.
Yeah, it froze, and we barely see that here on the West Coast.
Normally, we don't get snow.
Of course, you use a bigger size glass, not this one, but this would break if I would put it in water, just to show in the direction. And you put a holder, a support near to it, and you put the coil over the top, and you put it near. So you can see the fields transversally, which excludes the influence of the Earth's gravitation or something.
That's a good idea.
So just perpendicularly, and you will see how it goes. Or why not to use such a bigger size, plastic box with water? It will take more time to freeze. That's only the difference, but it will show better the fields, how they go. And you remember in the 107th Knowledge Seekers workshop, Mr. Keshe explained about the efficiency of a simple coil and the difference with the extension rod, and also said your idea may have applications, special applications where it's need for a large spectrum of fields.
Yeah,
remember that, about the broken nerves in the spine and the technical challenge of how to find to recover each layer. So there probably you will need to develop some special such a plasma tool like a pen, which every coil and every terminations gives a different spectrum to cover all. So it's not wrong what we are doing. It's a very good one, and it can be a way of development. Just I wanted to show the simplest way.
Okay,
some people always want to put something on it to make it more complex. Anyway, that's the way how to develop. But in the same time, we have to not forget the simple way which works.
I got one more question.
Yeah.
It's this we came across when I started doing the some freezing experiment, where actually different water, you know, when you got the tap water and when you freeze the tap water, or like Rick suggested to me, if you boil the water before, that it does, like the water seems to be much clearer in size, it has less bubble, it's actually a much more of a clearer result when you boil the water instead of using just normal cold water.
Yeah, yes. So see, the tap water always contains a lot of gas inside.
Exactly.
If you boil it, a part of that gas goes out. It's degassing a bit.
Oh, so it's degassing the water, basically.
Yes,
Yeah.
but also you can use simple distilled water, which was already evaporated, so it went over the boiling temperature or over the evaporation temperature.
But what happens is any water that's exposed to air will start absorbing air into it. And
of course, it's absorbing carbon dioxide in some percentage. It's absorbing oxygen some percentage.
And plain air.
If you have aquarium with fishes, you know that you have to give air, otherwise the oxygen will be consumed and the fish will suffocate.
Yeah.
So it's a water, and it's a much more complex thing. It's a very complex thing what we just see into a glass of water. And of course, if you have different minerals, different gases, that will come. I saw a nice thing on the Facebook shared by people. I don't remember exactly. It was who shared it first. It was the idea to add a drop of food coloring into the water, so it makes more contrast to the freezing test. Just a tiny bit like the end of the pin, a very little one, a very little quantity of food coloring if you can get. If you have a friend who is making cakes, ice cream, etc., in that case you can ask some very little food coloring and just put a little drop in the water, and it will give you something more visible.
You mean it would help show details?
Yes. It shows better contrast when it freezes. Yeah. You see darker and lighter spots.
Something else we've also noticed with the food coloring is the plasma will draw the food coloring out of the periphery water and deposit it into the ball of frozen plasma that we're looking at. It's a very, very interesting effect.
Yeah, those who are making wine for several years, for many years, so who are traditional winemakers, they know about that effect. So when you have the wine settled into a big barrel, let's say a 1,000 liter barrel, if you put a pipe in the center and you extract the so-called core of the wine, you will have a carafe like this of the best wine in the world, and the leftover, it's just good to let it on the drain. It will lose its quality if you take out the core of the wine. So that's why when you take out the wine from a settled barrel, you have to choose wisely where from you are picking it up, to not take out the heart of the wine, which holds it all together. So there is a layering like a plasma. It's a live matter. Wine is something live.
It boils and it heat up. You're right, eh? That's how you're right. There's a whole movement.
Yeah, you have heard probably about such a wine jelly, which is produced in a technology of about 14 years from certain kind of sweet wines. It's like a cube of jelly. You get a little cube. You eat it and wow, you feel very good, like if you took such a big bottle of wine. And it's just a small cube of jelly. Of course, it's not so dangerous like many people say, because when you go to taste the wines into a cellar, usually they leave that a little bit at the last. And first they give you to taste the light wine, or white wine, later the red wines, the heavier ones, sweeter and heavy at the end, and at the end a piece of jelly. So it's not that one piece of jelly which makes people to go asleep, but it's all the effect. But you will get the idea. It's a solidified wine by aging. It's 14 years to produce it. But there is a technology which is known in Bavarian Alps, which allows to produce that wine jelly in only 3 years. Of course, you need a quality sweet wine for that. But what's the technology? They put the sweet wine into a barrel, and after the wine is produced, after it's 1 year wine, they put it outside in the frost.
Oh, yeah, I was going to say, There is
So the
a wine they call ice
the water
wine.
freezes around, and the core of the wine, the plasma stays liquid in the center. Same like you have with this plasma pen test in the water. For some hours you see, or sometimes for days, a bubble in the middle, which is actually still in liquid state while everything is frozen around.
Oh, so
and
you
when
just
all the wine is frozen, they move into a room, into a warm room, that barrel. They put it into a larger tray to collect the wine, and they just take apart the rings and these wooden parts of the barrel. Sorry, I don't remember quickly the English term for
barrels,
The
yeah.
staves, barrel staves.
for the staves. They take the staves apart. They remove the ice, which is just the not valuable part, and they collect carefully the liquid. They put it into a smaller barrel, and they repeat with that smaller barrel the same process next year. And in 3 steps, they can produce that very concentrated wine in form of jelly.
I see.
It's understanding how it settles, how it's a plasma, so how it gets focused into the core. You see, you have a principal matter in the center, and you have the other states at the edges. The same technology ideas understood and applied since so many hundreds and thousands of years. Just it's not a lost knowledge, but people do it because they learn the steps and they don't understand why and how.
Hey Sandor, can you get a 5-gallon pail of that? Because it sounds delicious.
Yeah. I wonder if it's okay to export and import jelly as opposed to liquids. There's always problems with liquids.
Not only with liquids, it was a panic created after in London they found some supposed terrorists with some liquid explosives. So that's how the security experts, I don't know how experts, they just suddenly discovered in the 21st century that explosive can be in liquid form as well. Of course, we know the nitroglycerin before the Nobel's invention, the dynamite. It was known. It was a liquid, very effective and very dangerous explosive. And now suddenly they discovered a liquid can be explosive too. But they don't make distinction between a bottle of drinking water, and they don't let to take it with you at the airport. But you have to buy on a 10 times price that expensive one from inside, so it's a good business. They confiscate it to you, and I saw also expensive French perfume because it was more than the allowed 100 milliliters. It was maybe 120 milliliters. I just saw the customs officer just throwing it to the rubbish bin. A very expensive French perfume from the tourists. Of course, it's obvious it's not an explosive, but people forgot the purpose, and they just apply blindly and stupidly the rules without understanding the purpose. Not consideration. The purpose is stupidity by definition. Sorry for that. So about the transportation, always take care about what your post office or what your courier can accept, because there are some industrial products which are transported only by some companies and not by others. And if it's about the liquids, so check whether liquids are admitted and which quantities. So maybe if you have 2 milliliters of liquid, maybe no problem, but if you have 1 liter, it's already a problem because we are afraid it may leak or it may produce whatever.
Well, the reason I brought it up is the question of if we were to try to send GANs to another country or something, it might be a problem as a liquid, but perhaps if it was a jelly, it could be reconstituted just as easily as a liquid, as opposed to when it's dry, it tends to be hard to make it the same.
Check with your courier and with the customs office of the receiver country. Check with both. I don't think liquids are not transported because we have so many imported wines. Isn't it so?
Well, it's true.
Do you have a market any imported wine?
Yeah, that'd be
from South Africa, from Australia, from Europe, or from wherever. So there is a way how to transport liquids. Just check the rules how to do it.
Mm-hmm.
Don't have surprise that you don't declare what is it, and then it is stopped at the customs or at the security check. So get advice, talk to the people, talk to the officer who is taking care of that, and proceed in a correct way. There should be practically no problem for that, because you can send a bottle of wine, for instance. So why do you cannot send a bottle of Gans? But you have to apply for the correct packing, for the correct conditions, and for the way it's accepted by the post office or by the courier.
Yeah. What do you listed as contents? GANs, CO2 GANs.
They will not understand it. You have to list it as something which you can find in the customs tariff. You know,
That's
there is a
right.
story
That's
from
right,
the
exactly.
19th century when some British archaeologists wanted to take out of Egypt a mummy, a pharaoh's mummy, a mummy. And the problem was for the customs. They have no such thing in their list. So finally, after so long discussions, they asked what is made of, how it is produced. So it's a body which is bandaged and dried. Okay, so let's find something similar, because they have to put a customs tariff on it. So they agreed to be dried fish. So do you think of the soul of that pharaoh who was the leader of the half of the world to be evaluated as dried fish? It's funny, isn't it? So find what is matching into the customs tariff. You explain what it is, and you will find with help of a custom tariff specialist, customs officer, so what they can apply for that. So their main concern is when they see an article on an invoice or in a packing list, they have to classify it somewhere. So help them how to classify. The best is to discuss in advance. So you don't talk of GANs, so you say how it is produced, and he will understand something. It's a water, it's no salt inside, so what is inside? So there are some things which are produced by using metals like copper, like zinc or whatever, and he will understand something about, and he'll find somewhere. It's not a reactive, it's not a chemical. But it's a good point. So if somebody finds the way, in that case, please share to others, because it will be very helpful for others who want to send to their friends.
Well, there is one alternative way to do it if you're having trouble with the shipping internationally and stuff like that. The one way would be to get a letter of endorsement from your local MLA, MP, or anything like that. You know, any local government, and that's usually, I find, the best way to go around here, because a letter from that makes it just so much easier. And of course, immigration, or not immigration, but customs and customs immigration, you know, they'd be informed as well, and it always looks good. And plus, it'll also be precipice for the allowance of that openly.
Yeah, probably if you attach some officially looking document with some stamps and signatures and some authority on it, it will become easier, because they can refer to it, such a certificate or whatever.
This is Eva. Or you send them in very small quantities. I have some tube where there has been candy in, and they go to custom just fine. I've sent them all over the world by now.
Very good. How you're doing?
Oh, I just send them in small tubes where there have been candy in, and in small quantities, like just one letter at a time. So you don't have to write anything on the custom thingy.
So if you have such a small vial,
you have to make sure it goes by the post office as a letter.
Just a second, let me bring something. I found it. So if you have such a bubble pack envelope,
Yeah, it's
and you put it inside one piece or two pieces, and you seal it, and you can send it just like a letter back.
Right.
Yeah, I do like that.
Okay, okay.
That's
I
the,
thought of that, and what I found, what's a very interesting thing, the envelope itself costs more than the cost of production for one unit. So this would be the most expensive part probably in the costs. Thank you very much for ideas. So this is the way to go. So such a bubble layer, bubble pack envelope will make it. Thank you very much.
very good. Thank you for the demo there, Sandor. I'm not sure if I caught that on the actual. Let me just there. I didn't get it on the screen. I had the other. It didn't spotlight it properly. Just
so there are such kind of envelopes. This is standard for the. It has some code here. I don't know if you can read. It's I think made in Poland. It is Europe size. So this is for sending CD discs in it, and this other is just same surface but different shape. So this costs maybe 75 cents, and this costs maybe 40 cents. Something like that.
I think they might have a maximum thickness to go through something, but otherwise...
often you get such a small pack. So anyway, this will not fit into the the European mailbox, which has a small slit. But in that case, the postman will have to ring at your door, get your signature, and eventually a tip for next time to ring again, and not just to send you a small notification that you have to go to wait in a queue at the post office for your pack.
Right.
I think this works.
Good. Thank you.
You're welcome.
Also,
I think you can put 3 pieces inside.
Mm.
1 for your friend and 2 for his friends.
Mm-hmm.
To have something to share to others.
And
Never give only one health pen. Always give 2 or 3.
Otherwise, you get
because
people
he will
who are
show it to
jealous.
his relatives, to his friends, and everybody will want it, and will take it away, and he will be without one.
And one for the mailman.
Maybe.
In some countries, maybe.
Yeah, some countries you better.
We have been once in the East European countries border with an English businessman, and just right before the customs, he said, "Oh, I forgot a big bulk pack of some gadgets into the van. So where to put it? I just leave it there where it is." No, he wanted to hide it. So he hid it under the seat of the right side, just on the top of the battery. Guess when the customs officer opened the door, said, "Okay, stand up, show me what's on the top of the battery." That was the first thing. So what's that? Oh, you know, it's a tool with several gadgets. Okay, don't explain me. 2 pieces, 1 for me, 1 for my boss. That was many years ago in 1991.
Yeah. All right. Well, enough about customs and immigration, I guess.
You guys want to see something cool?
Yeah.
Always,
let's see something cool.
Okay. Well, here's Microsoft spying on me through the SVC host. Just give me a second here. Look at that, eh? Right there. This is a program called Hacker Deterrent, and it takes complete control of your browser traffic. Like, you can shut out. Here, I'll do a little example. If you go online and even to Facebook or anything, there's like 20, 30 IPs just sitting wide open and idle. It's pretty insane. And, you know, oh, there they go. Yeah, it's a very good program. You can get it at terraprivacy.com, and it's very good. You can disconnect with Google and, you know, all the search providers and everything like that, but still use them, and they can't actually see you on. So it's
it's good. So can you share in the chat the link, please?
Yeah, here, I'll just give me a second to type it out.
I just checked on an account which I didn't want to use more on the Google, what does it track? And I was amazed of all the computer activities.
Yeah,
Terraprivacy.com. Thank you very much.
it's very good. Very good. And what I usually do is I'll see if I can get it. I'll go online here and then do a screen share to see if, okay, here.
Yeah, let me say something. I knew about the tracking cookies and other things, but recently I observed I was using a different browser to log into to eBay, or even without logging, just to do a search on eBay for some product. And 5 minutes later on Facebook in a different browser, already I've got for a week only promotions about the product for which I did a search. And of course, that's not relevant because for me, because I did a search for a friend, so I'm not interested to purchase those products. But this is how the promotion works. They are checking your habits, what you are doing, and they just give you what they think you may be interested in. And in that case, if you do a search, that search will be not anymore the search is done by somebody else, but it will be a search specially tailored for you, which is not the best always.
Okay, right now I'm just going into Facebook here, and you'll see all this. Some is just the content. Usually, I disable most things. It does disable every ad though, so you can escape all the clutter of the ads. But this is just Facebook, just all that. That's just Facebook. And it can get pretty wild, especially when you do Google searches and stuff like that. And it's like pretty extensive, but it's pretty cool though. It's very accurate. Right here is where you see with the square around it, that means it's being accessed. And usually what you can do is shut down everything but what's being accessed, and then you just follow along, turn it on, it goes to the website or whatever. It's a little bit slower navigating, but at least it's a lot more secure. I'd probably say 80-90%. Very good program.
Thank you very much. Some time ago, I did some webmaster tasks, and I was willing to do such a search engine optimization. And I was shocked when I observed that if I do the searches, these are already different for me and different for others. So it's no conclusive. Thank you very much for sharing that.
Cybersecurity is a real big one.
Yeah, I have no secret. I'm transparent. Of course, there are such corporate secrets or group secrets which are not for public, so I don't like to be spied on. It's very useful.
That was Terra Privacy, for those who would like to know. TerraPrivacy.com.
Oh, and it's also free. The free version is absolutely great. The premium, you get a few more little tricks up your sleeve, but I'm just using the free version, and it works actually wonderfully because I got the boys right upstairs. So, yeah, and I can see them sit on there too, but I nail them before they even get a chance to check the feed.
Okay. What does anybody else have to offer here? I see Armen's on. What's up with you, Armen? Any news or revelations to share with us today? Maybe Libby? Libby, you have anything new going on in your plasma life?
I don't think Libby can speak. She's got people sleeping right next to her.
Oh, okay.
Fine.
I'll try to whisper. Barely. Yes.
All I can say is I really appreciate everybody that can speak and who can show things and send everybody love. And I still trying to envision a different place to be, so I can't participate in that. Thanks for remembering.
Okay, thank you. Okay. Anything else from anyone? What do we got? Anything to show here other than got a I guess I could show a little bit about my things that I've been dealing with in the last few days. Dealing with is a good word for it. Hassling with parts and trying to get things to rotate that are supposed to rotate and whatnot. What do you do?
Lower? Oh, sorry.
Okay. Yeah, so I'm just going to show the usual thing that I've had in the last couple of weeks is this rotating device. Let me spotlight and put on the video here. Okay. There we go. So yeah, the usual thing with been dealing with trying to get this thing to rotate one quietly and smoothly and without this humongous vibration and so on. I'm partly successful. I got it to go a bit smoother. Mess with the shaft and mess with a lot of stuff. It's a lot of messing around with this setup. It looks simple, but it's I didn't have the right shaft. I used a bolt instead of a proper shaft and whatnot. And it still has some issues with the globe being out of round and vibrating and whatnot. And it's a challenge to get it to run true. So in that light, I had something that I got some time ago, which is falling down here in just a minute when we get some more room. I got this this little lathe.
Is that a turn lathe?
Pardon me?
Is that a turn lathe?
A turn lathe? Is that what you call it?
Yeah.
Yeah, it's a little woodworking lathe. Now turn around so we can see the business end of it there.
It's a great tool.
There we go. So let me zero in a little bit on
Absolutely beautiful. Yeah, we
some
tried
of the
it.
details.
There's a motor right here. Pretty big fat motor. It's spec to 3500. You were saying, Rick?
Yeah, and the nice feature about this unit, which is on sale, is fairly cheap actually, about less than $100. It's got a variable speed here. So actually, yeah, we can try it.
Okay, let me plug it.
I don't know if you want to. Oh, it's not plugged in.
Unplug it.
Oh, okay.
Are you guys sure you tried it before? It looks like there's not even a speck of dust on it.
Yeah, I bought it some time ago, but I haven't used it yet. We just actually fired it up tonight here. So, I mean, it's pretty simple. Yeah, turn that up on that end. And it's got a low setting. That's the low setting.
I can go lower from here, no?
Yeah, I don't know. Maybe. But it might be hard on the motor. Yeah, not really. So it starts out at about 500 RPM. And you can control it fairly smooth. So it goes up to, normally it goes up to 3,500 RPM according to its statistics. But we've got it rigged up to the Variac up here. And the Variac is able to put out more than 110 or 20 volts. And so we can actually get, we've just taken an RPM reading at just under 4,000 RPM, which is a nice range for running some of the spheres that I want to run, for example.
And this end too, eh? The other end, is pretty, the whole thing is very perfectly centered, of course, you know. But at the other end here, you got the pin. So we found it quite handy that the railing and everything, you can actually center your reactor when you install it on your axle. You know, we're trying to look at a perfect tool to do it. This is an absolutely perfect tool to do it.
Right, yeah. It'll need a chuck here, or else mount the sphere on this plate. That can also be done. If you had a... Where's the bottom part of the sphere? That one over there, that one behind you. The big one. Big one there.
This one?
Yeah. Like if you had this sphere, for example, and that could be mounted on the plate, get that rotating nicely. That would be an interesting, nice, smooth, easily controlled way to go about it, which would be good. It's what I need for testing. So I was doing some work with the other one earlier. I was able to get a tiny little micro bubbles to form in the central tube of this, and it was all water except for one little tiny string of micro bubbles that were slowly moving across the very center of this. So I think that's interesting if I can get that effect. And the next step for me is I'm going to rotate this and actually use little treble speakers, basically like I'll have a speaker on each side here, and running at about around the 20,000 hertz, so it'd be still in the audio frequency but very high frequency, and maybe even a bit more than that, up to 25. I see there's some tweeters that are available at 25,000 hertz, and that would be good to so I'll have a speaker mounted on each side very close to this while it's spinning, little micro bubbles in the center of the spinning globe, and then I'll be able to control exactly where the bubbles are. According, I can raise the angle on this whole apparatus a little bit, and you can actually control exactly where those bubbles are. And with the tweeters putting out that ultrasonic signal, I might be able to get that micro bubble in there to
cavitation, implosion,
to cavitate and implode and cause the sonoluminescence while this is rotating. So that's the next little project that I got lined up here. I just got this thing sort of rigged up tonight, so it's going to take a little bit of fiddling around, but it's a nice, consistent work bed, you might say, compared to this guy, which is just gotten too funky. The bearings are loose even when they're brand new, and it's I'll fire it up there now.
This one?
Yeah, plug in it back into the Variac, and had it actually running not too badly earlier. Go ahead and see if I can get this camera lined up. But it started shaking like crazy, so I don't know if it'll be able to handle anything here.
Look at the reflection.
Will you be able to turn the light out?
Maybe too much. Like this?
Something like that.
That's good.
It's not too bad.
That's perfect.
You can't see the bubble in the middle, but you see it's shaking a bit there now, so it's
Like
not
an
lined
eye,
up.
I can see an eye there.
You're probably not going to get too far with it, but you can try. We can always try.
I'll just keep cranking.
Well, I guess so. She'll start shaking. I want to try to find that neutral point where it stops shaking. I don't know if we can get there. It might just start going into what? Sorry.
Your hand was in the way of the bubbles.
Yeah, I'm trying to keep it from shaking, and
it's really heavy shake. This one.
It's just not going to happen.
Do you see good there?
Let me try
Let
something.
me do this.
No, that's not going to work. No, see, that's the whole issue.
It vibrates so much that it can't even produce his normal tubes that it does. You know, it just.
Absolutely.
Yeah, and I can reset it in certain ways, but it's not easy and not fun. So that's why we're going to plan B here with the lathe, which has got more precise bearings and can take the vibrations and so on. But this thing's been a lot of fun. It still will be in many ways, because once I get a different set of bearings on this assembly, it's special because it's charges off.
Oh, you need to.
It's. Let's see if we can draw out the speed up a little bit more.
So good.
I don't know if it's.
Just watching it live is just amazing.
There it is.
Thank you for it.
Yeah, a little bit faster. Yeah, there we go. Good zaps.
Hey Rick, I could give you some nanotech insulation enough to put underneath the motor. It's shock what I use for the NRAM tech.
Alright, that's good. Well, it's still sparking anyway. Amazing how this thing generates enough of a spark to really make you pay attention.
And this is only the friction of that rubber again today, is it? Is it?
That's about it. Yep. It's the same effect as
Pretty amazing.
What do you call it? The
Van de Graaff?
Van de Graaff generator. Yes, thank you.
Hey Rick, I got a question.
Mm-hmm.
Do you guys think you can replicate that experiment that you have on your wallpaper key on your laptop there? Do you guys think you could replicate that experiment showing the?
At the moment, right now, no, I think.
No, not like right at the moment.
He's talking about. You remember when we did the tubing and the vacuum? I showed him the picture where we had all these rings, the plasma rings, and with the magnet, anode.
Right. Yeah, I have to.
It was pretty amazing.
That takes a bit of setup to do that, actually. But,
I think it'd be worthwhile to do a workshop on that one. I think everybody would be interested in that.
Yeah, the thing is, it's really hard to see with the video. I'm not sure if it. Well, I got a different camera now. It might show up better than it did before.
Everything needs to be in the dark, very dark, and then you see a beautiful glow. You get different glows around the magnet, bluer and more mauve or more violet color on the rings, and we achieve that only when we reach a certain vacuum, and if we pass that a little further, the whole phenomenon disappeared again, and it was one of those phenomenon that it was a transit phenomenon, I guess.
Okay, would you like to see some experiments that I've been working on, and
sure,
I was going to call it
go ahead there,
some silliness, but these are all my silliness. It represents many things.
Okay, do your thing there, Alper. Go ahead.
Okay, sir. I put the computer on. It's me. I'm very sorry to see me. Okay. Let me just see myself more. Okay. So what I have done was, you see this stacker, every part of it tuned in to different directions in terms of contour and the other way. Therefore, it's all random and it doesn't contain any sort of capacitors. What I've done was the silliness I represent, to collaborate the different technologies where they have other people tried levitating or lifting it, and these are called simply are lifters. What they do is they give extreme power, high frequency energy, high voltage towards them, and they lift, they levitate. You can find videos on YouTube. And so what I've done was I had to make one. And these are all experiments. I'm not proving anything, but just to eliminate things that we don't want to touch. And what I've done was nano-coated, sprayed them, and I made another one. I put, I suppose that's containing what I believe that is a hydrogen containing GANs in it, and more like water of it. And so yeah, let's look at it. Look, let me just hold it this way. I've seen these levitating, lifting it off the floor casually, just by giving them high voltage. And what I wanted to do simply is to collaborate our technology with it by nano-coating these outer surface, and inner surface still remains the same, but connecting with the magnetic, magnetical cables towards inner formation, and getting the energy from the stacker what I have designed, all totally random. And what happens is just strangely, I mean, I don't have to touch that silly thing. This is a regular compass. Well, that's the true north this way. And because the way I'm holding it is towards east, but that's just what happens. And from here, gets it from here, all anomalies have been I've detected. Strange things happened, and just to do the experiment the way I wanted to, but the hydrogen is being released. That's a phenomena that I've been wanting to find out, that blue ray, blue, I see blue. What is going on with this blue? And I had to see this blue. I've seen it with our stacker unit, but I haven't seen the one where it's being collaborated, so that it's being said that where the hydrogen is being released, where it's actually is happening, the levitation or sort of ionization is being happening. And it's all checks out legit. I don't know what to say really. I mean, I'm only collaborating to be able to find the sort of desired, like here, what I've done, silliness, but whatever. Look at it. It's all around it. The plasma is everywhere. The potential difference is being created by not its sort of numbers and shapes, but where it sort of it all has to be one in one component, where you sort of pinch one bit, a milli, like a tiny bit, it would still contain the whole idea. There has to be that kind of unification that has to be created in terms of, you can, yeah, lifting or whatever you desire. So that's what I'm playing with it, trying to create this purposely, this potential difference, and seeing it. And what happens is just like this high vibration is being developed, where we can perceive within our sort of perspective, and you can even smell the ayna as they are around it. And this is just what I've done, nothing really, and it works. But the trick is here, every single thing is being produced here. What I've done was, I haven't mixed all the GANs all together in all sections, and I have separated like what we do with the ping pong balls. And I've done CH3, all the radical leveling, and but I don't know. I mean, you tell me, guys. I mean, just tell me. This has to be achieved. This random composition of all the materials are being unified within even the little microscopic spectacle of it, has its own idea. Whereas if you have a bit of it, that means you can produce more of it, kind of idea. It's just, I don't know, like, this is where I am, and this is what I've understood. There are more of it, but for the moment being, that's all I can say. And if you have any questions, tell me. I'm not hesitated by using, this is a lifter, huh? The people lifted this, and there are hundreds of videos on it. I've nano-coded it, and the middle ball came with a big time patience, and it's like 6 or 7 months of waiting, of accumulation of, I don't know, lots of different GANs, mostly hydrogen. What gives me the indication of it is the right thing, and it's because I sampled it previously, the feeling of it, the understanding of it is possible to be able to perceive and sampled. Every step of what you do is just like not an idea, but maybe could be sampled like as a color or as a smell or a different thing. To me, this is can't be expressed. Therefore, it's just be shouted and just like mumbled like me. Yeah, the potential difference. There you go.
Okay, Alper, that was quite a
Thank you, sir.
random run around, but thank you for your insights there.
I got something, question.
Okay, go ahead.
Okay, I see how it attracts the compass. So what you should try to do is measure the frequency of the field for the lifter, because for most lifters, when you put a high voltage across, you'd want to check out the frequency of it, because if it's doing what I think it's doing as a lifter with the voltage, it's just repelling off the Earth's field, so you'd get the anti-gravity.
Well, I think I'm not putting any high voltage in it. That's the idea. I mean, the technology does that to be able to lift it. I'm not doing any of it. I'm not putting any high voltage. What comes is just from, look, I can hold it, I can lick it even. It just comes from the, you know, well, electricity, Mr. Edison, whatever, it's in California, therefore. So it goes from here and here, and yeah, as you said, really. Look, what matter here is to attach it to the earth, okay? And what I've done was just to plug the in. This is the in, this is the arrow, and just plug the, you know, you can see it easily. And Earth is just being an Earth. I don't know really. I mean, I talk, you know, I just say too much. But air is Earth, and us is Earth, and it's just Earth is matter in this equation. Everything, whether we create a capsule and where you're in it, but you represent where you come from, you resonate where you come from. It has it, and it's just your Earth, you know, whether you're wherever. And that's how people in other beings understands where you come from. Where you come from, and that's how they know who you are gradually. That's how they perceive, because we are Earth. I mean, that's kindly, and that's why I've understood. What happens is here is just like it comes from, of course, a stacker unit. Simple as that, which is CH3, CO2, CO2, and CO2, and comes and goes into this structure. Pyramids are not an implication, but what I wanted to see and combine my 3D is like, so I wanted to see where it might be able to, but then I know that it resonates all over the place. It's just collaborating with yourself gently and without trying to push yourself off the hill, kicking your bum towards the hill. Like, no need for it. Like, do the slowly, very slow, and in the middle, and try to understand whatever it is. What we see is here is just all silliness. Well, my intention is to gradually to separate this whole section, and comes from even here, and towards here is all unified, one component. What we're trying to do is, as when you do one component, that works. That is going to work. Like unified, it's circulated, it's you encapsulated it somehow. I don't know how you would do it. I tried to do it many times. Apparently, Mr. Keshe achieved it, even sat on it and broke it. And yeah, well, I'm so wanted to see the real deal, like as we're still here, like you know, we're here. I mean, 3D. We're not spiritual. I haven't seen myself on the other side. Perhaps I've seen, but still, we need to be able to see what is happening in this earth so that we could gradually pass. That's my way. I wish everyone to have to, you know, do it, collaborate it in some way or another, just to see it and convince themselves. Yeah. Oh, I talked too much again. I'm so terribly sorry.
Thank you, Alper.
You're welcome, sir. Thanks.
Okay. Any other questions or comments? Or people that would like to contribute something else?
I got something. One suggestion, which would be a cool little test to try, is that on the pyramid connected to the stacker, what you could try is you can make a pair of electrodes from old headphones that you could run off your PC or laptop, and then you could run a 9.6 hertz frequency on the.
Oh, and that's just teasing. I have done all of it. I'll show you something. It's just because you said it, and look, these are special speakers attached to my GANs ball, but still with this way and many other ways that I have tried with actual, it needs actual trembling, if you see what I mean. 3D, not as sound, but actual trembling. And then when it does, it sort of unified. I have video which I have accidentally came across with that. With it's like 9.2, well, whichever frequency that you do, it sort of unifies it. But I'm not saying it for anything here. I'm a sound man, sound engineer. That's why I'm a little bit into it, not to advertise myself at all. I don't care about any of that, but I had to try. You see, what happens is, look what's inside, and gold/copper GaNs, CH3 zinc, brass, copper, and CO2 out. So there are 3 layers in it, and I have given all the frequencies that you could imagine, and even I found hydrogen GaNs, not the GaNs, hydrogen frequency, so to speak, if it's ever true in its ability. I don't know. Yeah, it has its effects when you see it, but not that really. I mean, not even close. Why I have expected. It satisfies me in a moment because I've achieved to make it and constructed it. But now I know that intuitively, I know it's just not really. It's not going to work. So, but I still do it. Why do it? But I have to do it. That's why I've gathered from all of that. The more that I do it, it's more giving towards whatever the field you find a way to name it. I don't mind. It's giving towards that way, and then it comes back in a way where I don't even picture it, but I achieve. It happened. That's an experiment that I have done, which you can see. I've done many silly experiments. I've done that too, and it's just that way, I'm afraid. Yeah, you wish, it comes. That's towards the way where we sort of condition ourselves. Is the way we are that of that product and of that understanding, and collapsing the understanding. Mr. Keshe says it all, and it just covers it all in a. It just to me it makes sense. I just want to ask you what it is. Why is it so red? This is I call it my hydrogen reactor, so-called my fantastical machine, where I think I create some hydrogen in a faster way that I would suppose. And so there are 2 layers. Outer layer contains caustic. Yeah, I've gathered many of them, and inner layer, it was just distilled water, and then I added different salt in it, and so it turned into totally red. And I was wondering if that's because of the wood itself, or that's just the only thing that I can think of that make it possibly turn it into red color. And well, caustic is in it, and different types of salt in it. Keep adding adding it. You see, it's silly. I mean, it's free to laugh at me. No, please do that. And I add different voltages into it so that I can see the interaction in between while I'm adding in some current to the other side of it, but inner side of it is still remain. I've seen many significance in there, and it's just an experiment where I have, I don't know, look, red. It's really, it turned into silly red. You can see this salt is collected there. But nevertheless, sir, I'm working night and day to be able to understand all the facts, all the understanding, and I'm trying to do every single aspect of it, whether if I could collaborate it with one another, because that's what I think is the key, to be able to collaborate with one plant with this. Is that possible? It is possible. That's what I think is possible. Collaborating any field with itself. Look, previously we were asking it. I've done it with Mr. Q. I call him Q because he refused me, sweared at me in his first video where he was showing off his inventions almost a year ago. I didn't realize if he was doing a show, and I was like curiously asking really silly questions, and then he told me that you're a stupid man, and then I was like, okay, I didn't know. But this, you see, this, I have found this piece of wood in the middle of nowhere, and therefore at the same time of that gentleman, I have nano-coated it in his way, because I know Q A to Z, and or anything that has been released A to Z. So I have naively, that's how I wish I approach, not that to be able to discriminate him or anything in relation to it, but to bring people up and up, up and up, up and up, up and up. That's the only idea. There's nothing else. So simple is that. That's mix of GANs, where we have decided many year ago, CH3, CO2. CO2 makes no water. There's no water that has been talked about, and wood ash. Okay, and he's done it, and he was so surprised that it was so successful, and that is it. To me, he's right. It's an intelligent, and it's overwhelming. That's all I can say. I'm not gonna talk about on top of that, but it gives you that. If you have the edge, there you go. You're all there. You know what I mean? And yeah, that was it for him. For us, what it is, it just proves how Mr. Keshe was as a genius in his own way. So patient, being patient is the way. And you see, clock turn into a time where the caustic nanocoating matters. Why? Because the patience is the time that where you spend on it, where you wait. You just wait. You don't look, we wait. How? It's so desperate. You wait. Where you understand that concept, you're going to have much better results in terms of nanocoating and in terms of understanding the whole idea of everything, really. I mean, plasma is just everything when you adapt it into its own understanding towards it. You get you understand the feeling of it. Well, thank you. It's just overdone it. I know.
Just one more thing.
Yes, sir.
Can you go back to where it shows the ring around the pyramid, your coil around the pyramid there, just to the left of you?
Yeah.
Just left more. Oh, the other one, right behind you now.
Well, go ahead again. What would you like to know? What? This is 9,000 RPM goes, and I have several which I constantly move, because if it is going to happen, but look, that's the key. It happens immediately, right away. Doesn't take a time to charge it, because it's the right condition. It just does it. The time when we think it's gathering its own sort of revelation or time to do whatever it's going to do is irrelevant to us. It doesn't work that way. It just happens millisecond, and it's already has been happening. And I wish we had the tools to be able to see what's happening in our GANs buckets. It is really honestly, I don't know how to be able to do it, but if you record it and make it slow, you'll see on the surface of the GANs bucket, whichever you're doing it. I don't know, whichever your condition you're doing it. I also don't know. This is how it is with GANs. If it's going to work or not, I'm so sorry, but you will see really interesting gatherings and movements where with our conventional, our eyes that could see, we can't see it. We really can't see it. There are many other things. Yes, sir. Go ahead. What's that? Yeah, that's just about it, really. So we might be able to think that, oh, I got this stacker unit from the Keshe Foundation. It doesn't work. It was the past. It's past, isn't it? It's so funny. It's like to me is like million years ago. These feelings, because how you grow up, how you mature into this idea, and where everything comes towards you sort of immature somehow, where some people push it a little bit, but it doesn't matter. I mean, it comes to a point, I still think that I'm talking nonsense, and just like that, if you have questions, just carbon nanocoated. Let me give you legit information. My first nanocoated copper cables can move ashes. I can move ashes like they jump. I have a video. That's all I can say. I have legit and very solid video. And other than that, talking, it really does move, not just move it towards the way, but it brings it back. It pulls it back, if you can see it. And do you see what we're dealing with, guys? I mean, are we really seeing what we're dealing with? I don't understand it. And I'm sure.
All we're seeing, Alper, is your knees right now, actually.
Oh my God!
Nice knees and everything, but.
Sorry, sir. I'm sorry. I love you all. I've done enough. Thank you. I didn't realize. I'm so
good.
sorry.
It was good, Alper. I think we'll wrap things up here now, actually. So, is there anything else that anybody would like to present or show, tell, questions?
I'll show something real quick here.
Okay.
Just for some think about or whatever. Just give me a second here. It's from Michel Grenier, and it's very nice for the adaptation of coil shape and the isometrics of geometry. So here, just give me a second here. I'll do the screen share.
Is this going to be a picture that's a copyrighted picture by any chance?
No.
Okay.
Just 1 second here. There we go. Now, the conversation about the picture was actually about how in like the images and stuff like that of old hieroglyphs and like religion and stuff like that actually tell good detail about things. You know, so as you can see, the coil shapes and everything like that. So you got triangle, everything. Especially these ones is what we should be also practicing with coils. You know, like around that one around the pyramid, and even for the stacker units. You know, start working in some geometry and some in the actual coil itself, so it still has one flow, but it's more fractal than just straight up cylindrical. I personally, with this, I wouldn't put the light thing there. I'd put a lotus coil as what that middle representation would be. But yeah, just for food for thought.
I just want to add up that that picture you were showing there on the left side. This is the one with the light on the board. Yeah, that one.
This one.
Yeah, that one. This is a Tesla setup, actually.
Yeah,
Just tell people the story about that one.
I can't remember offhand.
Anyway, it was a Tesla demonstration where he actually, I think it's one of the first fairs that he did. That was one of his little demonstration.
These are electrodes then that plug into a Tesla coil, you mean?
And the whole thing was lining up, and so he was playing with this. And here on the right side, as Michel Grenier seems to be showing there, is the geometries of the relations between, or the setup between all these elements, and the geometry between them, and the way they can relate. Not sure exactly how it relates with that setup there with Tesla, but just a little something to add up there, that it's Tesla's demonstration there on the left side.
Okay, thank you, Guy, for that additional factoid. Okay, what else we got today? Anybody else like to bring up anything? Armen, you've been pretty quiet. Anything you'd like to say? Who else here? Or shall we wrap it up, Brett? You got any news you'd like to give us?
No, I just listening very carefully what you were talking.
Is that Armen?
That's Armen.
Oh, hi, Armen.
Hello. How are you guys? 1 minute.
Okay, let me turn.
Pleasure to hear you from you.
Turn the video back on here.
Yeah. Are you still working on your reactor? It was a beautiful one you showed the last time. The one with the double smaller reactor spinning and dual core.
I'm trying to finish it up this. This Chinese guy, you seen it in a trying to develop very nice.
You gonna show a screen share or a video?
I'm just gonna send you a Facebook link. You can open up and share. In a Zoom chat.
Zoom chat.
You have it? No?
No, we don't.
No, on the screen. You just go on the screen on a Zoom chat, on a meeting Zoom chat.
Okay.
Not your person.
Chat. Go to the bottom of the chat. I see Alper has the last comment. I don't see it there.
I'll send it later. Here.
Okay. Won't open.
One open?
It's got some kind of letters in front of it or something that's not right. You have to copy it differently.
Okay, I'll share it with you. I'll screen share it. Look how perfect it is then. Anyway, you can see this guy done perfect job.
Yes. Amazing job.
Yeah, with him we were working, the unit I showed it to you, he created. So
Oh, I didn't
we're
know.
gonna put it in the production.
Very stable, very sort of direct and solid.
Nice. So are these units going to be available, or are these just?
Yes, it's going to be available in Keshe Foundation.
Good.
Wow. How fast are they going, Armen?
It's, I think over 20,000.
Says 20,000 RPM, very stable.
Wow.
And is that with GANs inside or just the air?
No, this is nothing was inside, but just the air. So you can put this bulb. It's gonna like inner bulb, or you can add copper bulb. So it's both ways that you can operate.
Is that a polycarbonate sphere?
Yeah, but he's gonna create all of them: polycarbonate, or it's gonna be copper, or it's gonna be brass, whatever combination. It's a containment. Just understand, this is containment.
Yeah.
Of the fields, so, and it's perfect.
It really is perfect.
And how does it fit onto the sphere? Like that sphere, will it have a 5mm? I see it's a 5mm motor shaft, and it will be equivalent size shaft will go into the sphere, or it's always a problem.
But now it's a little bit changed. I think if we go back to 1 minute. Okay, let's say this is the different one. Right, yeah.
Make it big.
Right.
It's very stable.
Very stable, but it is still the ones that where we can't control the speed of it.
Yes, you can control the
unlike
speed.
your ones and your first videos where there are indicators where we can control it, like
Yes, you can control it. Now we're creating the one that you can control both sides. Actually, both sides is they have a motor shaft. So.
Also, then, yeah.
Nice.
I mean, I've seen it on Facebook. He shared it many times, and perfect as far as I think. And I'd love to get some of those. And whose videos are they? Is it in Chen Ling's video?
Yeah.
Okay.
These motors are from, I think, computer, what is it?
I have no idea.
Disk drive.
Disk drive, yes.
So just the middle bit where it is stabled, and it's a bit like your motors, Armen, and bit like.
Doesn't matter. You just need the rotation. So what motor only you need to to just centralize it perfect that you don't have a vibration. So the rest of it is easy. It's mechanical. This is easy. Now we need to load properly. That you have an interlink. So you can reach that, RPM that you can push the fields out in a stable condition. Now you can rotate this in between coils, like 3 stackers you have. If you put this inside, it's totally different.
You know, it is so doable, and it's so yeah.
And then just imagine that if you have a coils and you can rotate the field in the coils too, like if you close the loop. So you can have all magnetical plasmatic rotation with the coils or with the ball. They both are plasmatic. So one use centrifuge You know, the other one, you just, with the current, you rotate. That's why when you feed itself the coils and the stackers you have, if you look at it, you know, even with the capacitors, we feed the magnetical to gravitational.
Yeah.
We close the loop.
I really appreciate it when you talk. Thank you so much. I love listening to you. I mean, I'm nothing to appreciate it, but I just love to say it so that I have the opportunity to say it. That's what I'm saying. Yeah. Thank you so much.
You're welcome, guys. Now, the guy that showed, you know, so many setups of, you know, the coil reactors that he created, now he need a mixer. He need a mixer in the middle. That you have all the fields, now you need a mixer. So connect one ball and rotate it in the middle of your setups. We need to create rotation, magnetic wind.
Absolutely. Magnetic wind is like such a great way to describe it, really. It's just perfect. I love it. It's magnetic wind. That's what it is.
Anyway.
Yeah.
What do you think, Rick?
Well, Guy just suggested, what about the Rodin coil as a source of the wind?
What coil?
The
Rodin.
Rodin.
May I say something?
What is Rodin coil? Can you explain?
It's basically like a donut winding of...
No, you have it. It's your coils. That's why you have three stackers. Middle, the upper, and the bottom.
But you know what's Rodin coil is just like it's an impression of our 3D-ness. That's what we feel. It's there. It's a donut. We know it, and there you go. Look, it's in my hand. That's what you feel. But he's describing what he's feeling on towards the coil he's made. That's just what it is. Rodin coil. That works, of course. But it's my idea. I'm sorry. I just cut it in the middle. But yeah, it is the impression of the donut itself, where it's being created in our 3D-ness. That's what we feel. We have to make that. How? When we pass that threshold where we see the unified stacker unit, and then where we see the plasma, that's just it, really. That's just yeah, yes, that's how I understand it. Thank you. Sorry, I made it too large, wide, perhaps, but
I have a question. Don't you need at some point to submerge it all into water, with hydrogen water, to create a container for the entire field structure?
Liquid? Why would we need any liquid? Like, you don't need any.
Need a container.
Well, we need a container. Therefore, container is being created within itself by our creation of the. However, if you can find a unified field where you position, it's all different to any people. Like Arizona is going to feel different, and you're going to feel different, and everyone's going to feel different. Others, Yeah, that's just kind of similar to that feeling. It's not words, it's feelings. You don't actually talk about the field. Why would you talk about it when you're feeling it? You don't talk about it. It's just you need to sample that. That's why I've been telling many whatever you describe to yourself, it's all sampling. It's no actual understanding of what you don't understand anything. You see the color of it and you think it's this, but it's not that. It's just open the window. That's just it. We sample it, and then those samples comes towards back our yeah, it's just we sample it. I mean, no need to talk about more. We sample it. I think. Sorry. I mean, if I'm again.
Yes.
Yeah, we're in friends. You can tell me to shut up. I don't mind.
Well, Armen was going to draw something there.
I don't mind, man. Yeah, go ahead. Yeah, I love you.
I say
Sorry,
Armen was going to draw something there. I'm not sure if you want to continue with that, Armen, or no.
No, I just wanna like we together understand what we do. That we get the next step. If you have a ball and you have a second core, if you put the heavy materials in here, and let's say you put the hydrogen in here, still when you mix this heavy, meaning all your alkaline, all your oxides, so you just put a little bit of hydrogen in here too. The same thing, if you create more of a hydrogen condition in upper layer, you put a little bit alkaline in here too, that they find a connection and interaction. Now, if you rotate this and you have your coils, I'm sorry, maybe the color we have to change. What my point is, you're more of an electric world rig that how we can create, because we know this is all nano-coated in a plasma condition and it's coiled up already. Now we have all these interactions in between, which is the collection of the fields which we direct with the matter, meaning with the copper coils. And now we need to create a rotation in two coils, meaning the middle one and a magnetic, the upper one. Because we have the same condition in the middle ball. We have heavy material and we have a lighter material, and we have the same. Now, if we create a rotation in this coiling, and we create a rotation in centrifugal force in this, so we have an interaction of the fields. Even you don't need a rotation if you have properly load up your inner ball and outer ball, and you will start a rotation with small battery and LED. In the middle. This is, let's say, the battery and the LED. So you can create a rotation. You can create different way how to create a rotation in this loop. So you know the fields, they will interact with each other. So in the middle and the outside. So if you rotate this different way and this rotate anti-clockwise or clockwise, it will make a big difference. But the point is how to rotate, make a rotation in these coils. We measure the field. We know it's there.
If I may, just something that pops out in my mind because I was thinking about it before. You know, we got those little plastic that Sandor showed us at the beginning, those little plastic fitting that is using their tubings. And my thinking was at one point that maybe I can use some of these tubings and put the in and out through the coils and to pump some GANs through it. And so it...
You don't need that. Just understand. When you create already, you know, the GANs, so this field is radiating 360 degrees. So if you have the GANs pole inside, that pole now radiate out 360 degrees the field. It's already.
It's proximity.
Well, when you have at least 3 different ganses mixed, then you automatically will have a rotation in the fields, right? So what we're really talking about is being able to control them, speed it up, slow it down, change the direction. Isn't
Yes.
that right?
You can do this way. You can do squeeze the, you know, rotation of your coils or just the rotation of the ball.
But you already have rotation in the fields. We're just talking about being able to control it, right?
Correct. Not even control it. How you have to rotate the field. You have to create a magnetic wind.
But you should already have rotation. They have to be interacting, and one of the weaker one's going to catch up to the stronger one, or the other way around, whatever. You should already have rotation.
Yeah.
No?
But now you create a total rotation.
Mm-hmm.
Because if you why you coil when
Totality.
you coil,
Yeah. Unified. Whole thing is unified.
when you coil, this all fields not only, you know, you collect the fields from the copper coil, you collect the fields because you have this gap and this interaction too. So this interacts with this one, this interacts with this one, this interacts. So it's all collection of interaction that you can, when you measure your coils back end, you always, you know, measure certain voltage. Where this energy came from. Now you need to amplify it. Let's say, you know, I was, you know, a little bit reading about this delta and Y connections. If you look at it, your 3 reactors, coil reactors, if you connect together like delta, and you have one reactor rotating up, you can connect because they are already connected. You already, you know, the GANs you put on your coils, the GANs you put in a bowl which rotate up, they're already connected. So we can do the different configurations to understand how we can create that magnetic field, wind, which I think, you know, you can do it even with one reactor. If you have, let's say, 3 coil stackers, you can put it in one reactor that it rotates the field. Because if you use the same GANs to GANs code your coils, if you put it in a bowl, you still connect it.
Well, if you're away from it, miles away, you're still connected to it. So
definitely. So now you need to create interaction with the environment.
yeah.
We are trying this now in Arizona.
Oh, great! I love it. I love watching every. It's priceless. That's really good. To be able to use the space.
It's priceless. But everybody is doing the different, testings, different things. Still, have to understand how that these all fields are connected. They are in a GAN state, they are in a nano state, now they are free to interact.
Yeah, and even they even have a door to be able to step up the interaction and enter it. And well, these are all concepts where in its own title, it's just, oh my goodness, I couldn't believe what I watched. Really, I loved it. I mean, we translated it in Turkish. We tried. Yeah, it works lovely. I love it.
Rick, do you know much with the connections of delta and Y?
Connections of what? Pardon me?
Rick.
Oh, sorry.
You mean like this?
Yeah.
Oh, wow. Woo!
Yeah, I've just been looking into that more, and in regards to how it's used, in particular, for example, in a 12-volt alternator in a car. So you have you've got that is it the delta connection? I guess it is inside the alternator. And so normally you have 3 poles in the alternator, 3 cycles or 3 phases. And so you got normally 3 wires come out, but they go into 3 diodes, and then the current gets regulated, and it all ends up in one point going into your battery to charge your battery, for example. But I'm thinking, well, I've got an alternator, I'm going to take it apart, take a lead off of each one of those phases, so you have 3 wires coming out, and instead of bringing them all together at one point, using each of those to feed into a Y circuit, essentially. So use the delta to feed into the Y, and use each of these poles to feed into the pole, the Y, so that you end up with a rotating circuit happening in your other thing. When you turn the alternator, it should provide a pulse, bing, bang, bong, in each of those 3
well, there you go.
legs.
Now, Rick, okay.
So that would be the heartbeat. That's what I was trying to get to there.
I said what you said, that's fine. But now let's say if you have 3 stackers. This is from Alper. So you have 1 wire and 2 wire. It all has 2 wires, 1 in, 1 out. 1 in, 1 out, correct? If let's say you feed back this here, okay, this is, let's say, out, we do green, red, actually. And we do this in. Okay, connect this delta connection. Can you?
Okay.
Can you annotate?
You mean as far as this these 3 units go?
Yeah. So this you call in. Okay, this you call out. Okay, this is out. And this is in.
Well, I would think
So
that
you connected series, correct?
Yeah.
yeah,
This
like
goes
generally
here.
they would just be connected together with you know.
Okay.
Shoulder by shoulder.
Here.
Yeah,
And this
exactly.
one here. Now, when it feeds back, we create a circulation. So in this condition, so you can put a delta connection, I think. What do you think?
Oh yeah.
Okay, so you're saying that feedback wire there, is that like a nano-coated connection or something, or is it a direct
No, nano-coated
connection?
connection. This is all nano-coated.
Mm-hmm.
You see, where after a
One more thing, I'm not finished yet. I'm sorry.
I'm terribly sorry, sir.
Okay, let's say, consider, let's say this is a delta connection. But if we put one ball in the middle of it in a little bit height and start to rotate. Like let's say here, and these are the reactors. And this is a Y connection, no? Because it's still connected. What do you think?
Well, in the lower right corner, you put that extra loop there. Is that, do you mean that, or because you've got the one on the left corner, you
This
still
one?
want to have that? Yes, you still want that?
You feed itself.
Yeah, you need
Well, but
that.
I mean, you've already got it feeding from left one to the right one to the right one to the top one. So are you going to add an extra wire there connecting that back on itself there? Is that what you mean?
No,
Or you,
this one is a rotating ball. It's not a 3 stackers.
No, but I mean in the right corner one, that extra loop there. You don't need that, right?
Yes,
you do need that, Mario. What this is you're making like a battery capacitor system where your capacitor feeds back to your first stacker unit you're starting out with. The one on the bottom right-hand corner is your feedback stacker.
Okay.
So
I understand.
it's acting like a capacitor.
Everything
right.
has to sustain what it has to sustain. Let's say it's a proton or it's an electron. To sustain its like manifestation, it has to have a field which is, let's say, if let's say copper needs it's 59 or 60, to hold this itself, it's need the same to hold the fields. Whatever it's extra, it goes out. But to sustain its physicality, you're gonna call its manifestation, you're gonna call, it has to have feedback, meaning the fields, whatever, let's say if you need to sustain this for 10, so you need 10 back in, and whatever it's extra, it's anyway, it goes out. but this 10 is important to sustain. So it's the same thing. If you have a coils, to sustain the field, you need the feedback.
Okay. I see. Interesting.
Because all the interaction of the coils, you know, still, if you don't have a feedback, how are you going to sustain the field?
Yeah.
Well, but you do have a feedback even without that extra wire, don't you? Because if they're all connected in series, they're going from the one on the left bottom goes to the one on the right bottom, goes to the one on the top, goes back to the one on the.
Now if you have
you're adding an extra loop back.
Sustainable.
Yeah. So are you looping all of those back? You're adding an extra wire.
You can loop one back. You can loop all of them back.
Okay.
Is the way you have to test and see. But the point, my point is, to fields to sustain, it has a feedback. To sustain your physicality, you need certain energy every single day. So the proton, electron, or the earth, same.
Okay, I have another question then as well. It's maybe a little bit off this exact topic, but it was something Mr. Keshe said. All right, so you have your star formation basically here, which you will have a free plasma somewhere, you know, at the King's Chamber or wherever. Okay, and Mr. Keshe said, if you put another reactor below that to make a crystalline structure, that you will create another free plasma down there in the opposite side. And then the two free plasmas, when they interact, will create atomic hydrogen. You will open up a central core there that's strictly from the plasma.
Well, let me tell you something. What the only way to find put the next one to be able to achieve the previous one and synthesize its directions and what it tells you to do the next step. It's like, yes, of course, you can know all the chemistry and everything, but it depends on the direction where it's going to take you from. Well, yeah, I'm sorry. Bye-bye.
Okay, what you're explaining, you are explaining here. If you have a star formation, you create a free plasma in the middle. If you have this set up, you know, you create from the field of interaction of, let's say, 4, you create in the middle a free plasma. So this setup, what you do, it's for only to create this plasma. Afterwards, you don't need this to sustain, because now it's going to sustain its own field.
Yeah, but if I understand this correctly, if you put another reactor below it, like you have in that drawing on the right there, then you will create 2 free plasmas. Now you have the 2 free plasmas, they interact with each other, create an infinity loop in between them, which opens up a central core, which gives you, because neither one of those are both free plasmas. So you're creating a free plasma out of 2 free plasmas, if I got that right.
Wow. So what I can say is, why don't you accept what the plasma is giving you, and it interacts with you, and it gives you the understanding of all this to be able to explain it to us. These creations, or all of it, what we talk about it is our perceptions, and the dimensions of it is irrelevant. And we're creating its understanding of it. The more you're understanding, more you do act towards. You can control the plasma. It's just, I don't know. I don't understand it. It's just, it turns back to it every week. I think, I don't know. I should just shut up. I'm so sorry.
Okay, Rick, maybe we'll finish up.
Okay, Armen.
Oh, okay. Was it a little pun there? Sorry.
Just one more thing here. Have a great night, everybody.
Rick?
Yes?
This is Denny.
Denny.
I was going to make you twist my arm so that I would show what I was going to
Oh,
show.
I thought you were holding back, Denny.
But
All right.
it can apply to what Armen said.
Okay, please.
But not so. I'm going to just share my screen here for a moment. And I'm going to show you a tetra joint.
Tetra joint.
Tetra joint.
And yes, and you see this here.
Oh my goodness.
That's two of them.
It's a tetra joint. It's got 12 holes, and in these holes are designed to put PVC pipe.
Mm-hmm. Yeah.
And so
is this a real joint that's already made, or
I'm getting them made. I've got
okay.
I'm getting them made. I'm setting up my flight system with this, and so as you can see, there's 6 pipes coming out here, and this is what Mario would wanted to see, because this forms a star formation. I will show in future times how I'm going to utilize these. I can so all I was doing was presenting it for the moment, just to give somebody just to tantalize them for
a little teaser.
Yeah, it's a teaser.
Danny.
So
nice.
over the next few weeks, then you'll see the actual object, and then you'll see what I'm going to do with it, because what I'm setting up is I'm setting up a solid state group of coils that will come around this particular tetra joint. So that's it for now. You don't have to, that's just it. That's my
cool.
I'm going to have visions of tetra joints dancing in my head all night.
Just that the
Thanks, Denny. That was pretty cool. Alrighty, anybody else have any last minute things they want to jam in? Because we're ready to shut her down here. Alper, your video's on. Okay.
So that was a mistake. I'm so sorry. I just love you guys. I'm so appreciated. I love you all for everything.
And we love you too, Alper. And
kisses and hugs. Happy Christmas for whatever it means.
Yes,
just love you
that's right.
and hug you.
Christmas will be over by the time the next little plasma reactor group comes around here. But we do have another before the end of the year, so we'll have some end of the year flashbacks next time, and maybe we can reminisce about some of the interesting things that happened this year.
Didn't you mention a bit about what you had in mind there, or like that recollection of videos and little, something a montage you want to bring up maybe, or
you're gonna give away all my secrets?
Oh, that's supposed to.
Yes, and there'll be a video montage as well. No, I don't know. I just wanted to show this stuff. It's the highlights of what we did this year, basically, in this group.
It would be cool, actually.
So I got over 200 pictures, so we can slide through them in this slideshow.
That'd be awesome.
Thank you.
Dr. Keith, was that you?
Yes, it was. Happy holidays and much love and peace to all.
Very good. Thank you. Yes, that's right. And remember, it's now Wednesday, December 21st. And it's all downhill from here.
Equinox.
The days get longer, the sunshine comes out. I've noticed a difference even today. It was a crazy day with weather, but it started to get milder and nicer, and saw the sun twice. So, okay, Merry Christmas to everyone. And I think we'll end that for today. Quite a full session, lots of contributions. Thank you, everyone, very much for all your contributions in this this little group here. Appreciate it so much. Okay, so I'm going to end the live stream on that note, and we'll see you all next week.
See you guys.